పిల్లల్ని అడగమంటావా? వాయిస్ ఇస్ ఇట్ ఆడిబుల్? 400 మంది ఉన్నారు, ఇంతమందిని పెట్టుకుని నువ్వు ఇంత చిన్న తీస్తే ఎలా చెప్పు? Is it clear and audible? I mean, is it little bit low or that's fine? Voice, students. Fine. దీనిపై అసలు ఆఫ్ చేసి ఏసీ పెట్టి ఆఫ్ చేసి ఏసీ ఆఫ్ చేయి. కాంప్లెక్స్ వేరియబుల్స్ voice, is it clear? Okay, complex variables, just take the screenshots and we'll start the subject. Fine. Just basic definitions, you just take the screenshots and we'll start the subject. Mean the topics that we need to discuss. This. క్లియరింగ్ ఉంది దీని మీద డైరెక్ట్ పడుతుంది. Okay, let us start the definition of complex variable. So what is the definition? Remember, complex number means an ordered pair of real numbers. If you continuously enter, whether I have to teach or check what you are typing is typical for me. Anything is important, you can enter in question and answers, and don't enter in chat box. So ordered pair of real numbers is called a complex variable. Ordered pair of real numbers means, suppose x comma y, look there, x plus iy is a complex variable. Every real part of the complex number is written as x coordinate. Imaginary part of the complex number is written as y coordinate. So complex numbers must be written. Please focus on unnecessarily, please stop raising hands and unnecessary things. Focus on that. if I check each and every student, what they are typing, what they are raising, the class will not go
Sir,
smoothly.
sir, raise hand option తీసేస్తాను సార్.
This is it.
రేజ్ హ్యాండ్ ఆప్షన్ తీసేసేయండి. డౌట్స్ ఉన్నప్పుడు రేజ్ హ్యాండ్ ఆప్షన్ ఇచ్చుకోండి.
అక్కడ నువ్వు తీసేయటానికి కుదరదా?
నేను తీసేయచ్చు సార్, మళ్ళీ మీరు బ్రేక్ లో ఏమైనా డౌట్స్ ఇస్తే నేను తీసేస్తాను సార్.
ఓకే,
సౌండ్ క్లియర్ గానే ఉంది సార్,
ఓకే,
క్లియర్ గానే ఉంది.
ఓకే. Now every complex number should be written as point form. Real part x coordinate, imaginary part y coordinate. So this is called ordered pair. Ordered pair. X and y are real numbers. So ordered pair of real numbers is called a complex variable and is denoted by z is equal to x plus iy. So write the definition. An ordered pair of real numbers
స్క్రీన్ షేర్ పోయింది సార్.
is called a complex variable.
సార్ స్క్రీన్ షేర్ పోయింది సార్.
స్క్రీన్ షేర్ పోయిందా? ఒక్క నిమిషం. So an ordered pair of real numbers is called complex variable and is denoted by that is written like this: z is equal to x plus iy. Every complex number should also be represented by point form. Real part x coordinate, imaginary part y coordinate. Here x is called a real part of z and y is called imaginary part of z. Here z is equal to x plus iy is a complex variable. The complex conjugate of z is denoted by z bar. The complex conjugate of z is denoted by z bar, that is equal to x minus iy. Remember, z is a complex variable and its complex conjugate should be z bar is equal to x minus iy. Remember, if z is a complex variable, then f of z should be a function of complex variable. Next definition, function of complex variable. This is complex variable definition. Function of a complex variable. I mean, if corresponding to each of the complex number, there exists a corresponding another function that is called function of a complex variable. If z is equal to x plus iy is a complex variable, then the function f of z, then the function f of z is called a function of a complex variable. So f of z is equal to f of x plus iy. If z is a complex variable, then the function f of z is called function of a complex variable. F of z means f of x plus iy. Function of a complex number is also a complex number and is denoted by z. So function of a complex variable is represented by u plus iv, where u is real part of z, real part of f of z, where u is a real part of f of z and v is equal to imaginary part of f of z. This is the definition of function of a complex variable. Now, polar form of a complex number. What is the major purpose of remembering the polar form of a complex number? Suppose z is equal to x plus iy is a complex number. Sometimes it may not be possible to find the solution of some of the complex valued functions. In such cases, the solutions of all the type of complex valued functions can be evaluated by converting to polar form. So that's why one should know about the polar form of a complex number. Polar form of a complex number. Remember, suppose z is equal to x plus iy. Volume, is it clear or not? Please confirm. Voice, is it loud or not? Is it little bit low? Because some students are saying that voice is too low. That's why let me confirm. Perfect. It's too low. I'm using correct volume only. Let me check what went wrong. They will check. Remember, let z is equal to x plus iy be a complex variable. What are the polar coordinates? So whenever you want to convert from Cartesian coordinate system to polar coordinate system, substitute x is equal to r cos theta. To convert from Cartesian coordinate system to polar coordinate system, substitute x is equal to r cos theta, y is equal to r sin theta. And moreover, this is x square plus y square is equal to r square, because it is r square cos square theta plus r square sin square theta. So x square plus y square is equal to r square. From this, r is the radius vector. So radius cannot be negative. So that's why r is equal to plus root of x square plus y square. And you observe this. I want to find from this y by x, find the value of y by x. Y by x is equal to r sin theta by r cos theta. RR cancel, then it should be tan theta. So tan theta is equal to y by x. Tan theta is equal to y by x. This is theta. Tan theta is equal to opposite side by adjacent side. Then hypotenuse should be square root of x square plus y square. So this theta is called amplitude. Be careful what I am saying. Tan theta is equal to y by x. So from this theta is equal to tan inverse y by x. And everyone please observe, tan theta is equal to y by x. So theta is equal to tan inverse y by x. Theta is equal to tan inverse y by x. This is called amplitude of a complex number. Also called theta is equal to tan inverse y by x is called amplitude of a complex number, also called argument of a complex number. So you people have to remember that theta is a multi-valued function. Theta is a multi-valued function. Multi-valued function means for one point x comma y. Multi-valued function means for one point x comma y there exists one and only one theta value. Single valued function means for one point x comma y there exists one and only one theta value. Multi-valued function means for each set of x and y, means for one point x comma y there should be more than one theta value. Then theta is a multi-valued function. So everyone has to remember that theta is a not single valued function. By substituting one x and one y, you may get more than one theta value, which is the multi-valued function. That's why theta is called multi-valued function. Suppose theta value lies between minus pi and plus pi. Theta value lies between minus pi and plus pi, including plus pi, then theta is called principal value. Theta is called principal value of argument of z. Remember everyone, before going to find the principal value of a complex valued function, please ensure that your theta value should lie between minus pi and plus pi. What is the general value of theta? Everyone should remember. I said theta is a multi-valued function. No, I will show you the problems. If theta is a multi-valued function, then the general value of theta, if theta is the solution, theta plus 2n pi is also the solution. I will explain with an example also. Just wait for 5 to 10 minutes. If theta is the solution, then theta plus 2n pi is also the solution. Then the general value, of theta is, general value of theta is theta plus 2n pi, where n is equal to 0, plus or minus 1, plus or minus 2, so on. I mean, I said theta is the solution. Then theta plus 2n pi is also the solution, where n is any integer. Don't worry, what I have explained here, we will be doing problems on this model. Everyone has to remember that if theta is the solution, theta plus 2n pi is also the solution, where n is 0, 1, 2, 3, or plus minus 1, plus minus 2, so on. What is the topic? Polar form of a complex number. Z is equal to x plus iy. We did not write polar form. Let us write polar form of a complex number. Next slide. Z is equal to x plus iy is a complex number in Cartesian coordinate system. X value r cos theta plus I into y value r sin theta. From this is r into cos theta plus sin theta. That is r into e to the power of I theta. Everyone has to remember the polar form of a complex number is cos theta plus I sin theta will be written as r e power I theta. So from now everyone should remember that the polar form of a complex number is z is equal to r e power I theta, where r we have already found. Look here, r value square root of x square plus y square. And theta value tan inverse y by x. Whenever you want to convert from Cartesian coordinate system to polar coordinate system, r is replaced by this, theta is replaced by this. But it is not your choice. Here, the quadrant theta should be tan inverse y by x. X and y lie in which quadrant you need to consider. Suppose x positive, y positive, then first quadrant value should be considered. I mean theta value must belong to first quadrant. Suppose x negative, y positive, then your theta value should be in the second quadrant, means 90 to 180. The quadrant in which that number lies, that is important when you are writing theta value. Please be careful, very, very careful when you are writing theta. So this is the polar form of a complex number. Anyhow, let me give some clarity. Please remember these values, may be helpful when you are solving the problems. This is, be careful, this is theta is equal to 0. This is theta is equal to, this is theta is equal to pi by 4. This is theta is equal to pi by 2. This is theta is equal to pi. This is theta is equal to, just note down these notations. This is theta is equal to 3 pi by 2. And what is this? This is 45 degrees, 90 degrees. This is, and 1 minute everyone, here theta value should be expressed in terms of radians only. When you are finding the principal value, theta should always be in terms of radians. Radians. Now 0 degrees, 45 degrees, this is 90 degrees, this is 135 degrees, this is 180 degrees. Now this is theta is equal to 5 pi by 4, that is 225 degrees. This is theta is equal to 315 degrees. Now everyone should listen to me carefully. This is theta is equal to pi by 4. Theta is equal to pi by 4. Its image should also be theta is equal to minus pi by 4. This is theta is equal to pi by 4. Its image is this. Its image is theta is equal to 7 pi by 4. So that is also theta is equal to minus pi by 4. Theta is equal to pi by 4. Mirror image is theta is equal to 7 pi by 4. Also written as minus pi by 4. This is theta is equal to 3 pi by 4. Its image is theta is equal to 5 pi by 4. That is also written as minus 3 pi by 4, because 3 pi by 4 image is 5 pi by 4, also written as minus 3 pi by 4. This is theta is equal to 90 degrees. Theta is equal to 90 degrees. Exact mirror image is theta is equal to 270 degrees. So it is also written as theta is equal to minus pi by 2. Theta is equal to minus pi by 2. Please do remember that. Note. Some basic notations only. Please remember. First, Z1 is equal to X1 plus I into Y1. Z2 is equal to X2 plus I into Y2. Z1 is X1 plus IY1. Z2 is X2 plus IY2. So therefore, this is argument of Z1, Z2. First to find Z1 into Z2. X1 plus I into Y1 plus X2 plus I into Y2. Multiply these two. You will get a new value. That new value should be found using this formula. Theta is equal to tan inverse Y by X. That is called argument of Z. Then argument of Z1 into Z2, when you apply that formula, will be argument of Z1 plus argument of Z2. Now argument of Z1 by Z2 is equal to argument of Z1 minus argument of Z2. See, some students continuously entering. What they are entering, I am unable to see here. Now argument of Z1 minus argument of Z2, and moreover, please remember Z bar whole bar. Z bar whole bar is equal to Z. Next, Z1 by Z2 whole bar is equal to Z1 bar by Z2 bar. And next, f of Z whole bar is equal to f of Z bar. For example, tan Z whole bar is equal to tan Z bar. For instrumentation engineering, it was asked for 1 mark. Tan Z whole bar is equal to tan of Z bar. Remember, Z into Z bar is equal to modulus of Z whole square. Z into Z bar is equal to modulus of Z bar whole square. Similarly, Z1 plus Z2 whole bar is equal to Z1 bar plus Z2 bar. Suppose it is minus, here also it is minus. We do some problems on basics which we were already asked in the gate. Because what you are typing, I cannot see. It is showing the last student what they entered. It is showing the same thing only. Mr. Hashwant Kumar Mardana, what you are mentioning, sir, is Bandla Ganesh. What went wrong with me? Mr. Hashwant, please be careful while you are commenting anything. Still some students continuously asking. Remember the timing till 9 o'clock we have. Please be careful. If you attend in the middle, that is problem. Unnecessarily don't blame any faculty without if you attend in the middle. Actually, there may be a system problem here. I think apart from that, everything is fine. Unnecessarily blame. See here once again. Till now we have 10 pages. Right from the beginning, see, from the beginning, page number 1. From now, everyone should be careful. Page number 2. Page number 3. Page number 4. Page number 5. Page number 6. Polar form of a complex number, because I want to convert from Cartesian coordinate system to polar coordinate system. Z is equal to x plus iy is a complex number. X r cos theta, y r sin theta. X square plus y square is r square. So r is equal to root of x square plus y square. So I want to find tan theta. Y by x is equal to r sin theta by r cos theta. R cancel tan theta. Theta is equal to tan inverse y by x. This theta is equal to tan inverse y by x is called amplitude of a complex number or argument of a complex number. Moreover, theta is not a single valued function. Theta is a multi-valued function, because when you substitute one x value, one y value, then you will get more than one theta value. That is what I am showing in the problems. So theta is a multi-valued function. More than one theta value for given set of xy values, then it is called multi-valued. Suppose this theta value lies between minus pi and plus pi, including plus pi, then theta is called principal value of argument of a complex number. What I am saying is, suppose in this model, theta is the solution, then theta plus 2n pi is also the solution. For example, suppose cos theta, suppose 1 can be written as e power I pi, for example, look here. You should not get confused. For example, 1 can be written as cos 2 pi plus I sin 2 pi. Here, theta value 2 pi plus 2n pi, 2 pi plus 2n pi. Substitute theta is equal to 2 pi, 2 pi plus 2n pi, n value 1, 2 pi plus 2 pi, 4 pi. If theta is the solution, theta plus 2n pi is also the solution. Theta value 2 pi plus 2n pi, n is equal to 1, 2 pi plus 2 pi, 4 pi. So cos 4 pi plus sin 4 pi also 1. Take n is equal to 2. 2 pi plus 2 into 2, 4 pi. 2 pi plus 4 pi, 6 pi. Cos 4 pi plus I sin 4 pi. I mean cos theta plus I sin theta, theta value 2 pi. Then 2 pi plus 2n pi is also the solution. Regarding complex variables, in this model, if theta is the value, theta plus 2n pi is also the solution. This is what I am saying. Unnecessarily entering there in question and answers, unnecessary meaningless things, please focus. Z is equal to x plus iy, x value r cos theta, y value r sin theta. Because I am converting from Cartesian to polar, r common, cos theta plus I sin theta, cos theta plus I sin theta e power I theta. Z is equal to r e power I theta is a polar form of a complex number. So these are the values. Next properties. Now properties. Now problem start. Still, if anybody cannot understand the problems I am teaching now, you can ask. Problem number 1. But please be careful. Unnecessarily blame the students, unnecessarily blame the faculty. If you have a doubt, I will be there to clarify. One student unnecessarily entering, Bandla Ganesh, what's your attitude? I don't know. Are you really preparing for GATE exam? I don't know. I'll talk to you at the end of the class and tell me what's your problem. The value of I power I is this problem given in the GATE. Given in the GATE, electronics engineering, electrical engineering, instrumentation engineering, 2012. Moreover, the same problem was given in the GATE, mechanical engineering, 1996. It was given ISRO exam, electrical engineering, 2015. You were asked to find the value of I power I. Let us find the value of I to the power of I. Some students still continuously disturbing voice. Is it clear or not? Perfect. Okay, I power I. Listen to me. I to the power of 5. This can be written as. Tell me, I to the power of 5 can also be written as. Cos pi by 2 plus I sin pi by 2. cos 90 0, sin 90 1, 1 into I, 1 into I whole to the power of I. This is equal to cos 90 plus I sin 90 should also be written as e to the power of I pi by 2. E to the power of I pi by 2 whole to the power of I. E power I pi by 2 value cos pi by 2 plus I sin pi by 2. And observe I into I square. I square value minus 1 into pi by 2. So e to the power of minus pi by 2. The value of I power I is e to the power of minus pi by 2. Because root of I power I means root of minus 1 power root of minus 1. Its value e power minus pi by 2. E value 2.718. Power minus pi by 2. Pi value 3.14. Similarly, you write this problem. Otherwise, some students have a doubt regarding the previous problem. Regarding the previous problem, suppose you are unable to write what I have written here, cos 90 plus I sin 90. You are unable to write. You can still write like this also. Observe. I to the power of 5. I can write it as 0 plus I into 1. 0 plus I into 1 whole to the power of I. Suppose you are unable to solve any complex valued function, then immediately express that complex valued function in its polar form. X plus iy complex number polar form representation is x plus iy complex number polar form representation is r e power I theta. R e power I theta whole power I. First of all, we don't know the value of R. I have already given the polar form of a complex number. The polar form of a complex number is R is equal to square root of x square plus y square. That is square root of x square plus y square, that is 1. This is R value. And I have already given theta value also. Theta value, remember, regarding these models, theta value should lie between minus pi and plus pi, including plus pi. That is mandatory. Theta value must be the principal value. Tan inverse y by x. This tan inverse y by x is called argument of a complex number, also called amplitude of a complex number. Please observe here, x coordinate 0, y coordinate 1. X coordinate 0, y coordinate 1. Every complex number should also be represented by point form. Real part x coordinate, imaginary part y coordinate. 0, 1 lies on y axis. Therefore, the point 0, 1 lies in the first quadrant. First quadrant range 0 to 90. So theta value should lie between 0 and 90 only. Tan inverse y by x. It is y value 1, x value 0. Theta is equal to tan inverse 1 by 0. That is tan inverse infinity. Tan inverse infinity value pi by 2. Tan inverse infinity value pi by 2. Substitute r and theta values in equation number 1. Equation number 1 implies that I to the power of 5 is equal to r e power I theta. R e power I theta, r value 1, e power I into theta value pi by 2 whole power I. So I into I square value minus 1 into pi by 2. Problem number 2. The square roots of minus I R. You are asked to find two roots of minus I. Square roots of minus I means two roots of minus I. Be careful, everyone. Square roots of minus I means it would be written like this. This is square root of minus I. This square root of minus I is also written as minus I whole power 1 by 2. Actually, we need two roots of minus I. Suppose you are unable to find two roots of minus I, then this minus I should be converted into polar form. First of all, minus I will now be written as 0 plus I into minus 1 whole power 1 by 2. This is X. This is Y. X plus IY complex number, polar form representation is R e power I theta whole power 1 by 2. Let it be equation number 1. X plus IY is a complex number in Cartesian coordinate system. Then the corresponding polar form of the complex number is R e power I theta. R e power I theta. Let us find, we need to find two roots, not one root. We need to find two roots. So R is equal to, what is, we need to find R value. Square root of X square plus Y square. What is X value? X value 0, Y value minus 1. So this is 0 square plus minus 1 whole square. That is 1. And everyone should remember here X coordinate 0, Y coordinate minus 1. X coordinate 0, Y coordinate minus 1. 0 comma minus 1. Now be careful. Here 0 comma minus 1. 0 comma minus 1, where it lies? X coordinate 0, Y coordinate negative. And you observe this 0 plus I into minus 1. 0 comma minus 1. Now theta is equal to tan inverse Y by X. That is tan inverse. What is Y value? 0. X value minus 1. Observe that tan inverse Y by X. Y value minus 1, X value 0. Y value minus 1, X value 0. That's fine. X 0, Y negative. Remember, your theta value should lie between theta value should lie between minus pi and plus pi. Everyone has to remember, first theta value should be a principal value. Principal value means theta has to lie between minus 1 and plus 1. Tan inverse of minus x, that is minus tan inverse x. That is minus tan inverse 1 by 0. That is minus tan inverse infinity. That is minus pi by 2. But one thing everyone should remember, R is the radius. Radius value fixed. Theta value will vary because we need two roots of minus I. Square root, like cube roots of unity, fourth roots of unity, like that. Square roots of minus I, cube roots of minus I, nth roots of minus I. So we need two roots. If two roots of minus I, then we need two theta values. One theta value minus pi by 2. Another theta value. What is another theta value? That is what I'm saying. If theta is the solution, to find another theta value, use the formula. If theta is the solution, theta plus 2n pi is also the solution where n is equal to 0 plus minus 1 plus minus 2 so on, where n is equal to 0 plus minus 1 plus minus 2 so on. N is equal to 0, 1, 2 so on. If I take n is equal to 0, we get theta. Theta value minus pi by 2. Let us find theta plus 2n pi. Theta value minus pi by 2. N is equal to 0. Theta value minus pi by 2. N is equal to 1. Theta value 2 pi. Then it is 3 pi by 2. Suppose you are asked to find 3 roots of minus I. 3 roots of minus I. Then you need to write theta values. Among these 3 theta values, first theta value should lie between minus pi and plus pi. That is minus pi by 2 here. Next value theta is equal to 3 pi by 2. To get the next value, take n is equal to 2. To get the next value, take n is equal to 3. We just need 2 theta values only because square roots of minus I. Substitute these 2 theta values in equation number 1. Equation number 1. Radius 1, theta values will vary. Equation number 1 implies that root of minus I is equal to r e power I theta. First theta value I am writing, r value 1 e power I into first theta value minus pi by 2 whole to the power of 1 by 2 is there. Whole power 1 by 2. Sorry, whole power whole power 1 by 2. It is not writing, I think. Just 1 minute, students. Now, sorry for the interruption. There is a small error. E power minus pi by 2 into 1 by 2, that is e power I into minus pi by 4. So root of minus I is equal to e to the power of I theta, e to the power of I theta, that is cos of minus theta plus I sin minus theta. First root, this is the first root, cos of minus pi by 4. Cos of minus pi by 4, cos pi by 4, that is 1 by root 2. Sin of minus pi by 4, that is minus sin pi by 4, that is minus 1 by root 2 into I. Now another theta value 3 pi by 2. So substitute another theta value now in equation number 1. R value 1, e power I into theta value 3 pi by 2 whole power 1 by 2. So this is e to the power of I into 3 pi by 2 divided by 2, that is 3 pi by 4. Root of minus I is equal to e to the power of I theta. E to the power of I theta formula, cos 3 pi by 4 plus I sin 3 pi by 4. Cos 3 pi by 4 means cos 135, that is cos 90 plus 45, that is minus sin 45, minus sin 45 value minus 1 by root 2, sin 3 pi by 4, sin 135, sin 90 plus 45, that is cos 45, that is 1 by root 2. So the two roots of minus I are, the first root is this, second root is this. These are the two roots of minus I. Suppose you are asked to find cube roots of minus I. Cube roots of minus I, first I took n is equal to 0, n is equal to 1. To get cube roots of minus I, take n is equal to 2, you will get another theta. We can find n roots also. Next problem. Write down. The principal value of logarithm of minus 1 plus I root 3 is logarithm of minus 1 plus I root 3. Same story. Real part of the complex number will be x coordinate. Imaginary part of the complex number will be y coordinate. So this is actually, we don't know how to find ln minus 1 plus I root 3. Unable to find the solution of any complex valued function, please express that complex valued function in its polar form, that is r e power I theta. What is r? Square root of x square plus y square root 4, that is 2. Theta is equal to tan inverse y by x. Quadrant is important. Here x coordinate negative, y quadrant positive. Therefore, it is a second quadrant. Remember everyone, x coordinate negative minus 1, y coordinate positive plus root 3. that that point lies in the second quadrant range 90 to 180. Regarding this model, theta value should lie between minus pi and plus pi. Your theta value should always lie between minus pi and plus pi. First theta value. Tan inverse of minus root 3. Tan inverse of minus root 3, tan 60 degrees, tan 30 1 by root 3, tan 60 minus root 3. But what is the value of tan 120? Tan 90 plus 30. Tell me the value of, this is tan 2 pi by 3. Tan 2 pi by 3 means tan 120. Tan 120 means tan 90 plus 30. That is minus cot 30. That is minus root 3. So theta value minus root 3. Substitute r and theta values in equation number 1. Problem completed. Be careful everyone. Your complex number lies in the second quadrant. So theta value should lie between 90 and 180. Between 90 and 180, at which point your theta value should be minus root 3. That is 120. So tan 120 minus root 3. So theta is 120. Substitute r and theta values in equation number 1. Logarithm of minus 1 plus I root 3 is equal to ln r into e power I into theta value 2 pi by 3. This is ln AB. This is A. This is B. ln AB formula ln A plus ln B. ln A plus ln B. Logarithm of e to the power of f of x. That is f of x. Logarithm of f of x is f of x. Problem number 4. For a function of complex variable w is equal to ln z. Where w is equal to u plus jv and z is equal to x plus jy, where j is equal to root of minus 1. Du is equal to constant lines get mapped in the z plane as set of radial straight lines set of concentric circles set of confocal hyperbolas set of confocal ellipses. This problem given in the GATE Electronics Engineering 2006. How to solve the problem? Please think. Everyone remember W is equal to ln(z). W is equal to ln(z) will represent straight line or concentric circles or confocal hyperbolas or confocal ellipses. Let us solve. Moreover, one more condition was given, that is U is equal to constant lines. Let me check. What you are given? W is equal to ln(z). Z means what? X plus iy. I means j. I am unable to find the, don't write ln a plus ln b. Logarithm of a plus b is not equal to logarithm of a plus logarithm of b. So you should not write like that. We are unable to find ln x plus iy. So that's why immediately convert that x plus iy in its polar form. X plus iy polar form is r e power I theta. This is A, this is B. ln A plus ln B. ln AB is ln A plus ln B. I theta means j theta, no issue. I theta or j theta. W means what? U plus IV or U plus JV. If you write U plus JV, please make it as j theta, j theta. This is ln R. Do you know ln e power f of x? That is f of x. Compare the real and imaginary parts. Comparing the real and imaginary parts. So from this, U is equal to ln R. U is equal to ln R, V is equal to theta. We were already given in the statement of the problem that, look, U is constant lines. They mentioned U is constant. So let it be C. ln R is equal to C. This is ln R to the base E. From this, R is equal to e to the power of C. E constant, small e value 2.718. E constant, C constant. So e to the power of C, let it be K. Squaring on both sides, R square is equal to K square. Do you know, in regarding the polar form of a complex number, we have already assumed that R is equal to square root of x square plus y square. Please check. Regarding the polar form of a complex number, R is equal to root of x square plus y square. So r square is equal to x square plus y square. In place of r square, I have written x square plus y square is equal to k square. Now here k is arbitrary constant. Arbitrary constant means it can be replaced by any real number. K is arbitrary constant. It should be replaced by any real number between minus infinite and plus infinite. So if I take k is equal to 1, we will get a circle of radius 1. K is equal to 2, we get a circle of radius 2. K is equal to 3, we get a circle of radius 3. K is equal to 4, circle of radius 4. So therefore we are getting different circles with same center and different radii. Therefore the answer should be set of concentric circles. Note down this. Given two complex numbers Z1 is equal to 5 plus 5 root 3 I and Z2 is equal to 2 by root 3 plus 2I. The argument of Z1 by Z2 in degrees is it was given in the gate. I have already given the formula argument of Z1 by Z2. Argument of Z1 by Z2 formula argument of Z1 minus argument of Z2. Do you know theta? Theta is equal to tan inverse y by x is called argument of Z1, Z. Theta is equal to tan inverse y by x is called argument of Z. So argument of Z1 that is theta 1. Argument of Z2 that is theta 2. Theta 1 means what? Argument of Z1. Argument of Z1 means tan inverse y by x, y1 by x1 because first complex number. Argument of Z2 means tan inverse y by x, but for the second complex number no, y2 by x2. Do you know this is x1, complex number representation is x1 plus x plus iy. Complex number representation is x plus iy. First complex number real part x1, imaginary part y1. Second complex number real part x2, imaginary part y2. This is tan inverse y1 by x1, 5 root 3 by 5. Minus tan inverse y2 by x2, that is 2 by 2 root 3. 2 divided by 2 root 3. 0. This cancel, this cancel. This is a tan inverse root 3 minus 1 by root 3, that is tan inverse root 3. Answer 0. Do you know, suppose whenever you are asked to find roots of a complex number, nth roots, cube roots, 4 roots, 5 roots, you can apply the same formula. Otherwise, I'll give you a simple definition. Nth root of a don't worry, at the end, after completion of complex variables, the whole notes PDF format will be shared. Nth root of a complex number let z is equal to x plus iy be a complex number. So from this, w is equal to z power 1 by n. What is the polar form of a complex number? R e power I theta whole to the power of 1 by n. This is equal to r to the power of 1 by n e power I theta whole power 1 by n. This is r power 1 by n e to the power of 5 into theta by n. But you need to write general value. General value means, as we discussed already, if theta is the solution, then theta plus 2n pi is also the solution. I will write in the next slide. General value means till the end of the complex variables, whenever you come across theta is the solution, then immediately you can write theta plus 2n pi is also the solution. E power I into theta plus 2n pi. In place of n, I will write k. If theta is the solution, theta plus 2n pi. Already n is there, that's why I have written k. Here theta is the solution. Theta plus 2n pi. I into theta plus 2n pi by n. In place of n, I have written k. This is r power 1 by n e to the power of phi theta. Formula cos theta plus I sin theta. Cos theta plus I sin theta. What is k here? Where k is equal to 0, 1, 2, so on n minus 1. Suppose you want to find n roots of a complex number, nth roots of unity. Nth roots of unity means in place of z, take 1 power 1 by n. And then we can find nth roots of unity or nth roots of minus I, any value can be found using this value. To get the first root, take k is equal to 0. To get the second root, take k is equal to 1, so on. Suppose when you take k is equal to n, when you take k is equal to n, by taking n, k is equal to 0, whatever the root you get, same root will be repeated when you take k is equal to n. If you take k is equal to n plus 1, when you take k is equal to 1, whatever the answer you get, same answer will be repeated. For k is equal to n plus 1, so on, roots are repeated. Same roots will be repeated. Basics completed. Once complex variables completed, notes will be shared. In PDF format, I'll share. Next definition. Differentiable function. Write down definition. A function f of z is said to be differentiable at z naught if limit f of z minus f of z naught by z minus z naught as z tends to z naught exists. If this limit exists, then f of z said to be a differentiable function at z is equal to z naught. That is, f dash of z naught is equal to limit f of z minus f of z naught by z minus z naught as z tends to z naught. But one thing everyone has to remember, look here, this is z, this is z naught, this is z. Z tends to z naught. Everyone remember, in calculus means real variables, x tends to 2. In calculus, in real variables, x tends to 2 means x is approaching 2 either from left side or from right side only. Whereas in complex variables, z approaches z naught means z can approach z naught along this way, z can approach z naught along this way, z can approach z naught along this way, z approaches z naught along this way, z approaches z naught along this way, z can reach to z naught along infinite number of possible paths. So whenever you want to find out limit f of z minus f of z naught by z minus z naught as z tends to z naught, you need to calculate f dash of z naught value along this direction, along this direction, along this direction, along infinite number of possible directions. If all possible directions will give you the same answer, then only you can say that f dash of z naught exists. Means f of z differentiable at z is equal to z naught. But doing in this manner along infinite number of possible paths, even one day will not be sufficient. So that's why using the definition, we should not confirm whether it is differentiable or not. Some other procedure must be adopted for clarifying whether one function that is to be differentiable or not at z is equal to z naught then. Now let us see the definition of analytic function. Analytic function. Listen to me, everyone. Neighborhood of one point. Neighborhood of z naught means, everyone should be careful. Neighborhood of z naught means center of the circle must be at z naught and radius should be very, very nearer to 0 but not 0. Neighborhood of z naught means center of the circle at z naught, radius of the circle should be very, very nearer to 0, but not 0. Just for the sake of visibility only, this much size I have taken, but radius almost 0. This is a neighborhood of Z0, means center of the circle at Z0, radius of the circle is a delta. Delta means a number that is very nearer to 0 but not 0. That is a neighborhood of Z0. Finally, my intention is one function f of z that is to be analytic at Z0, means that function should be differentiable not only at Z0, it should also be differentiable everywhere inside the neighborhood of Z0. It should also be differentiable at all points inside this neighborhood of Z0. What I said, analytic function at Z0 means differentiable function at Z0 plus also differentiable at all points in the neighborhood of Z0. A function f of z is said to be analytic at the point Z0 if it is differentiable at Z0 and also differentiable at all points in the neighborhood of Z0. Analytic function at one point means a differentiable function at that point plus also differentiable at all points inside this neighborhood. The analytic function is also called another name of analytic function is also called a regular function or holomorphic function or monogenic function. These are the synonyms of analytic function. Analytic function at one point means differentiable at that point, also differentiable in some neighborhood of that point. Similarly, analytic function in some domain. Analytic function in some domain means it is differentiable everywhere inside that domain. A function f of z is analytic in some domain if it is differentiable, everywhere in the domain. Definition: entire function. Entire function is also called integral function. Remember, one function that is analytic at all points on the complex plane. Finite part of complex plane means everywhere on the entire xy plane except infinity. Finite part of the complex plane means at all points on the xy plane except infinity is called finite part of the complex plane. Any function which is analytic everywhere on the finite part of the complex plane, that is called entire function. A function f of z which is analytic everywhere on the finite part of complex plane is called entire function. Entire function is also called analytic function. Everyone remember some of the examples, not some of the examples, all examples of entire function means examples of the function which are analytic everywhere, sin z, cos z, sin hz, cos hz, e power z, e power minus z, polynomial. What do you mean by polynomial? Z over any non-negative integer, z to the power of any non-negative integer is called a polynomial. Among infinite number of different functions available, only these functions are analytic everywhere. Means only these functions are differentiable at all points on the xy plane except infinity. Notes will be uploaded, don't worry. This note. Entire function. What do you mean by entire function? After the class, I'll talk to everybody, those who have doubts. Entire function means what? The function which is analytic everywhere. Entire function means analytic everywhere. Analytic everywhere. Entire function means analytic everywhere function. What is analytic function? Analytic at one point means differentiable at that point plus also differentiable in certain neighborhood of that point. So analytic function means differentiable at that point, also differentiable in the neighborhood of that point. And in calculus, we have every differentiable function is continuous. Entire function means analytic everywhere. Analytic function means a differentiable at that point plus a differentiable in the neighborhood. And calculus differentiable function means continuous function. Any function which is a differentiable at any point, that is by default continuous at that point. But converse of this statement need not be true. Means continuous function need not be differentiable, continuous function need not be analytic, continuous function need not be entire. But converse need not be true. Converse of the statement need not be true. Means continuous function need not be analytic. If f of z and g of z are analytic functions, then f of z plus g of z, f of z minus g of z, f of z into g of z, f of z by g of z. Okay. Converse need not be true. Next. Next slide. If f of z and g of z are analytic functions, then sum of two analytic functions, product of two analytic functions, division of two analytic functions, also analytic. But here g of z not equal to 0. Sum of two analytic, product of two analytic, division of two analytic functions, analytic. Next slide. Next slide. (28F). I will upload the notes, don't worry, in PDF format. 28, 29. I will give the break 7:15 to 7:30. I will give the break. Next. I will always help you. The only thing you need to cooperate. Cauchy-Riemann equations. There is a theorem statement It is a theorem. Necessary and sufficient conditions for f of z is equal to u plus iv to be analytic. Necessary conditions. Del dou u by dou x is equal to dou v by dou y. Necessary conditions del u by del x, dou u by dou x short form, del v by del y, dou v by dou y short form, del u by del y minus del v by del x means dou u by dou y is equal to minus dou v by dou x. These are called Cauchy-Riemann equations, simply CR equations. See, these are necessary conditions for the function to be analytic, but not enough, but not sufficient to prove one function analytic. Next slide. Sufficient conditions. Sufficient conditions dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y are continuous functions of x and y. Dou u by dou x is a continuous function, means dou u by dou x value at any given point is a finite number, then dou u by dou x is a continuous function at that point. Next, dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. These are called Cauchy-Riemann equations. Finally, I need clarity. When one function is said to be analytic, let me check. Actually, I'm talking with big volume only. There might be some problem with vacuum. I'll talk to them. I'm talking with loud voice only. Still I can raise my volume. Listen to me everyone. To confirm one function that is to be analytic at any given point, please listen to me and note down as well, and be careful what I am saying. CR equations are necessary for any function to be analytic but not sufficient. So that's why let me speak, and what I'm saying you need to concentrate. Look here everyone, first to verify CR equations. CR equations are not satisfied at any given point, then the function will not be differentiable at that point and hence not analytic also. CR equations are not satisfied at any given point, then at that point function will not be differentiable and hence not analytic as well. Suppose CR equations are satisfied at any given point, don't blindly assume it is analytic. That's why let me say, look here, these two sufficient conditions. Everyone be careful what I'm saying, and notes also I will dictate. These two sufficient conditions. We have two sufficient conditions. These two sufficient conditions are satisfied at any given point. At that point, the function is said to be differentiable. Suppose these two conditions are satisfied in some neighborhood of a point, these two conditions are satisfied at all points inside some neighborhood, then it is analytic at that point. Both sufficient conditions are satisfied in some neighborhood of one point, that is analytic at that point. These two sufficient conditions are satisfied at all points on the xy plane except infinity, I mean finite part of the complex plane, then the function is entire function. Entire function means analytic everywhere. So what I said, condition number 1, if CR equations not satisfied at any point, then the function will not be differentiable. Remember, if one function cannot be differentiable, it cannot be analytic as well. And hence not analytic at that point. If both sufficient conditions are satisfied at a point, then the function is differentiable at that point. Next slide. Next condition, just 2 minutes, 2 more conditions are there, I'll give the break. Next condition, if both sufficient conditions if both sufficient conditions are satisfied, in the neighborhood of a point then the function is analytic at that point. If both sufficient conditions are satisfied, on the finite part of complex plane. Finite part of complex plane means at all points on the xy plane except infinity. Then the function is entire function. We'll continue after the break. Let's have 15 minutes break. After the break, we do problems on these verification purpose regarding whether one function that is to be analytic or not at any given point. Let's have a break. And I'll ask them to modify this system. Thank you. Let's have a break, students. Let's have 15 minutes break. మాట్లాడమంటారా? If both sufficient conditions are satisfied everywhere, బ్రేక్ ఇచ్చా. అందరూ వాల్యూమ్ స్పీకర్ ఇదే పెట్టారు. వాయిస్ ఒక్క నిమిషం, నేను స్క్రోల్ డౌన్ అది చేస్తే చాలా లేట్గా వస్తుంది. నేను పెట్టుకొని లాగా voice. Students, anybody online, please cross check my voice. Is it clear and loud and audible? If anybody is in the online, please confirm my voice. Is it clear? I mean, not better. Is it perfect or better or clear, or let me know, Mr. Harish. Sufficient? Is it perfect and sufficient? Okay, fine. Thank you. Okay, is it clear? Loud? Thank you very much. problems. Problem number 1. The complex function f of z is equal to z into imaginary z is differentiable at 0, 0. Analytic at 0, 0. Analytic everywhere except at 0, 0. Option D, analytic everywhere. Analytic everywhere means entire function. Next slide. Next slide. What is given? F of z is equal to z into imaginary z. F of z is equal to imaginary part of z. Imaginary part of z means y. Z means x plus iy. Imaginary part of z is y. Z into imaginary part of z. X plus iy. Imaginary part is y. So f of z is equal to x into y. Xy plus I into y square. Assume the real part is u. Real part is u. Imaginary part is v. U is equal to xy. V is equal to y square. First, we need to verify CR equations. Suppose CR equations are not satisfied, it will not be differentiable and hence not analytic. So in order to confirm that, we need to verify CR equations first of all. Dou u by dou x, y. Dou u by dou y, x. Dou v by dou x, 0. Dou v by dou y, short form v suffix y, 2y. Remember, dou u by dou x is not equal to dou v by dou y. I want to write in the next slide, dou u by dou x is not equal to dou v by dou y. Similarly, dou u by dou y not equal to minus dou v by dou x. These are CR equations. And be careful everyone what I am speaking. Whenever CR equations are directly not satisfied, I mean dou u by dou x are directly not equal to dou v by dou y. In that case, we need to verify CR equations at points. At points means at what points? At option points. At option points. What are option points? All options containing 0, 0 only. So therefore we need to check at 0, 0. At 0, 0 means x value 0, y value 0, dou u by dou x 0, dou u by dou y is x value also 0, dou v by dou x already 0, dou v by dou y is 2y, y 0, 2 into 0, 0. So dou v by dou x 0, dou v by dou y 0. CR equations are satisfied. CR equations are satisfied. Condition number 1, CR equations are satisfied at 0, 0 means at 0, 0, dou u by dou x value 0, dou v by dou y value 0, and dou u by dou y value 0 minus into dou v by dou x 0. CR equations are satisfied at 0, 0. What is both sufficient conditions are satisfied at one point, it is differentiable at that point. Both sufficient conditions are satisfied in the neighborhood of one point, that is analytic at that point. So one of the sufficient conditions satisfied. Now let me check another sufficient condition is ux, uy, vx, vy. Look there, ux, uy, vx, vy are polynomials. Polynomial means variable power non-negative integer. Variable power non-negative integer. Ux, uy, vx, vy are polynomials which are continuous everywhere. Which are continuous everywhere. Every polynomial is continuous everywhere, analytic everywhere. So ux, uy, vx and vy are polynomials so these are continuous everywhere, but we are checking at 0, 0 only. CR equations satisfied at 0, 0, ux, uy, vx, vy continuous everywhere, so they should be continuous at 0, 0 as well. Moreover, both sufficient conditions are satisfied now at 0, 0. Therefore, it is differentiable at 0, 0. In case both sufficient conditions are satisfied in the neighborhood of a point, then it is analytic at that point. Now, I will consider neighborhood of 0, 0. Neighborhood of 0, 0 means take one of the neighborhood point. One of the neighborhood point is x coordinate 0.1, y coordinate 0.2. This is one of the neighborhood of 0, 0 point. X value 0.1, y value 0.2. If I take x value 0.1, y value 0.2. If y value 0.2, ux value 0.2, vy value 2 into 0.2, 0.4. Then ux not equal to vy. Means in the neighborhood, CR equations are not satisfying. Means at one of the neighborhood point, x 0.1, y 0.2, dou u by dou x not equal to dou v by dou y. That means CR equations are not satisfied in the neighborhood of a point. Therefore, it will not be analytic at the point 0, 0. Conclusion is both sufficient conditions satisfied at 0, 0. Therefore, f of z is differentiable at 0, 0, but f of z is not analytic at 0, 0. Reason I will write in the next slide. Reason, next slide. Reason, CR equations not satisfied in the neighborhood of 0, 0. Next. Write down. The complex valued function f of z is equal to 2xy plus I into y square minus x square is option A, differentiable at 0, 0. Option B, same options, analytic at 0, 0. Option C, analytic everywhere except at 0, 0. Option D, analytic everywhere means entire function. Analytic everywhere meaning entire function. Let us check. Next slide. Two xy plus I into y square minus x square. A real part of the analytic function, let it be u. Imaginary part of the analytic function, let it be v. First to verify CR equations. Because the CR equations are not satisfied, then it is not analytic, not differentiable, and hence not analytic as well. That's why we are finding CR equations dou u by dou x, and that is 2y. Dou u by dou y, that is 2x. Dou v by dou x minus 2x. Dou v by dou y is equal to 2y. Look, CR equations are satisfied. Dou u by dou x value is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. Look there. CR equations are satisfied. Dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. With be careful what I'm saying, without substituting any point directly. Sometimes CR equations, like in the previous example, look here. In the previous example, look here. CR equations not satisfied here. Dou u by dou x not equal to dou v by dou y. But at 0, 0, CR equations are satisfied. Sometimes direct CR equations will not be satisfied. But by substituting at some particular point, CR equations may be satisfied. In this example, without substituting any point directly, CR equations are satisfied. That meant for CR equations are satisfied everywhere. Everywhere means at all points on the complex plane. CR equations satisfied everywhere. Everywhere means in place of x, you write any finite real number. In place of y, you write any finite real number. Definitely CR equations are satisfied. That means CR equations are satisfied at all points on the xy plane. Moreover, dou u by dou x, some students please raising the hands. What is the problem? I don't know. Please enter in question and answers. I'll cross check and I'll clarify your doubt. Please don't raise the hand. Instead, please enter in question and answers. I'll check and answer. Remember, moreover, CR equations are satisfied everywhere. Moreover, dou u by dou x, dou u by dou y, okay. Moreover, dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, all are polynomials. Polynomial means x power real, x power non-negative integer, or y power non-negative integer. Means x power or y power non-negative integers of 0, 1, 2, 3, so on, which are called polynomials. So dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, which are polynomials. So which are continuous everywhere. Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y are polynomial. Polynomial means variable power non-negative integer. Every polynomial is a continuous everywhere, differentiable everywhere, analytic everywhere. Or polynomials, next slide, are polynomials. Next slide. Which are continuous everywhere, which are continuous everywhere. So remember, both sufficient conditions are satisfied everywhere, means at all points on the xy plane. Therefore, f of z is analytic everywhere. Therefore, f of z is analytic everywhere. Analytic everywhere means entire function. Similarly, note this problem and try yourself. The complex valued function f of z is equal to x square plus y square plus I into 2xy is, try later, similar to the same previous problem options only. Same previous problem options only. Analytic everywhere. Answer similarly, try this problem also. The function f of z is equal to modulus of z whole square is, try yourself, same previous problem options only. Answer differentiable only at origin, that is at z is equal to 0. Differentiable only at origin. Third cannot be analytic. Third is analytic everywhere. Sorry, 1 minute, 1 minute. 1 minute. It is not analytic. Not analytic. Third one is not analytic. Yes, third one not analytic. And next, write down. The complex valued function f of z is equal to 5z bar plus 4 is, option A, a nowhere differentiable. Option B, differentiable only at 0, 0. Analytic, option C, analytic at 0, 0. Option D, analytic everywhere. Let let me check. F of z is equal to 5z bar plus 4. Z bar. Z bar means x minus iy plus 4. So f of z is equal to write the real terms in one bracket. What happened? Now write the real terms in one bracket. 5x plus 4 one bracket. Next to minus 5iy. Minus 5iy can 5 into minus iy. Minus 5iy. I can write plus I into minus 5. So u is 5x plus 4. U is equal to 5x plus 4 and v is equal to minus 5y. Find dou u by dou x. 5. Dou u by dou y 0. Find dou v by dou x 0. Dou v by dou y minus 5. Observe dou u by dou x not equal to dou v by dou y. Of course, dou u by dou y is equal to minus dou v by dou x. One CR condition satisfied, another CR condition not satisfied. That means CR equations not satisfied. Let me speak. Whenever CR equations are not satisfied, then you need to check at the points. Check at the points means at 0, 0, at 1, comma 0, like that. To check at the point 0, 0, we need to substitute x0, y0. But we don't have x and y in ux, uy, vx, vy. Therefore, CR equations are nowhere satisfied. Any point, x value, any finite real number, y value, any finite real number, you substitute. Dou u by dou x not equal to dou v by dou y. Even one condition not satisfied, then it is not analytic. It is not differentiable. CR equations nowhere satisfied. Not only at one point, at all points, CR equations not satisfied. CR equations nowhere satisfied. Nowhere CR equations satisfied means it is nowhere analytic. Nowhere analytic. Therefore, f of z is nowhere differentiable. Sorry, if it is nowhere differentiable, then it cannot be analytic also. CR equations are now CR equations are nowhere satisfied, so it is nowhere differentiable. Nowhere differentiable. Note this and try yourself. Note this and try. The complex valued function f of z is equal to x plus e power minus y cos x. Please don't raise the hand because it is continuously blinking here. Then it diverts my concentration. It is still blinking. Those who have raised, 7 students raised their hands. It is continuously blinking. I don't know whether your intention is diverting my concentration. Please don't raise the hand. Screen is freezed. 1 minute. 1 minute. 1 minute. One minute. I will check. Please stop. I will check. One minute. I will check. Is it visible? Please confirm. Students, is it visible or not? Please let me know. Is it visible? Sri Charan, is it visible? Sri Charan, unmute yourself and let me know. Sri Charan. Okay. Bhavani, please unmute and let me know. Is it visible? Is it?
No, sir, it is not visible.
Okay, okay, fine, fine. One minute. I stopped the class. Please hold on a line. I stopped the class. Wait for 2 minutes.
Hello.
Please wait.
Students,
Please unmute yourself.
Not visible, sir.
Hello,
not
sir.
very good, sir.
I'm not teaching anything. Just wait for 2 seconds. They'll come and rectify. I'm not going to teach anything. Wait for some time. Just 2 minutes. అది వాళ్ళ స్క్రీన్ ఫ్రీజ్ అయింది అంటున్నారు. ఎక్కడున్నాడు ఈ అబ్బాయి?
Hello, sir.
Please mute yourself. They will rectify the issue. ఇది స్క్రీన్ ఫ్రీజ్ అయిందని చెప్తున్నారు ఏంటి? నేను ట్రై చేశాను ఇందాక. అదేంటి ప్రాబ్లం అయితే ఒకసారి చెప్తే చెక్ చేసుకుంటాను నెక్స్ట్ టైం ఇష్యూ అయితే.
ప్రాబ్లం ఏం లేదు సార్.
స్క్రీన్ ఫ్రీజ్ అయ్యిందని.
ఫ్రీజ్ అంటే దీనిపైన క్లిక్ చేసి ఇట్లా ఉంటే కొద్దిసేపు అది ఆరెంజ్ కలర్ లో చూపిస్తుంది.
దీని మీద క్లిక్ చేస్తేనా?
దానిపైన ఇక్కడ ట్యాప్ అయి ఉంటే
పొరపాటు టచ్ అయి ఉంటేనా? దాని మామూలుకి రావాలంటే
నార్మల్ ఏం లేదు, అది ఆటోమేటిక్ వచ్చేస్తుంది.
ఇందాక నుంచి అలాగే ఉంది, అదే సడన్ గా చేంజ్ అయిందని. Students, let us continue. This is the last slide and this is okay. This is the fifth problem. Please have a look. This is the fifth problem. Okay, do one thing. Visible or not?
Visible, sir.
Visible. Okay, fine. Note this. Just take the screenshot. Take the screenshot. Now, note this. Take the screenshot. Write down option A. Not analytic yet 0. Option B, analytic only at 0. Option C, analytic only at only at 1. Option D, option D, analytic everywhere. Try yourself. Option D correct. Try yourself. Similar to the previous problem models only. Next problem. Going to the next slide. Note down. Yes, option D, analytic everywhere correct. Note this problem. For what values of A, B and C the complex valued function f of z is equal to minus x square plus xy plus y square plus I into ax square plus bxy plus cy square is analytic. They have already mentioned, suppose the given function is analytic, what are the values of a comma b comma c? If it is analytic, by default it will satisfy CR equations. Just by comparing CR equations, we can get the values of a, b, c. Real part of the analytic function, let it be u. Imaginary part of the analytic function, let it be v. So find dou u by dou x. Find the value of dou u by dou x, that is minus 2x plus y. Similarly, find the value of dou u by dou y. Dou u by dou y is bx plus 2cy. Similarly, find dou, sorry, this is 1 minute. This is dou u by dou y, that is x plus 2y. Dou v by dou x, already complete. Dou v by dou x is a into 2x, 2ax plus by. Dou v by dou y, that is bx plus c into y square derivative 2cy. They have already mentioned it is analytic. So to get the values of a, b, c, compare CR equations. Dou u by dou x is equal to dou v by dou y minus 2x plus y is equal to bx plus 2cy. Bx plus 2cy. Compare x coefficients both sides. Left side x coefficient minus 2, right side x coefficient b. So b is equal to minus 2. Compare y coefficients both sides. Left side y coefficient 1, right side y coefficient 2c. So from this c is equal to 1 by 2, b is equal to minus 2. Next another CR equation, dou u by dou y is equal to minus dou v by dou x. Dou u by dou y is x plus 2y minus into dou v by dou x minus into 2ax plus by. This is minus into 2ax minus into plus minus by. Compare x coefficients both sides. Here left hand side x coefficient 1, right side x coefficient minus 2a. So minus 2a is equal to 1, so that a is equal to 1 by minus 2, minus 1 by 2. Similarly, note this problem and try yourself. Find the values of a comma b comma c comma d e. such that the function f of z is equal to x cube plus a x square y plus b x y square plus 2y cube plus I into c x cube plus d x square y plus ex y square minus y cube plus 1 is analytic. Try yourself. A minus 6, B minus 3, C2, D3, E minus 6. Try yourself it later. Next. Write down f of z is a function of a complex variable z is equal to x plus iy given by f of z is equal to iz plus k into real part of z plus I into imaginary part of z. For what value of k will f of z satisfy the Cauchy-Riemann equations? Try yourself it later. It was given in the gate. Mechanical Engineering 2018. Option B is the right answer. Next, definition. Yes, last option is Y. This last option is Y. So option B correct. What do you mean by harmonic function? Any function phi which satisfies Laplace equation is called harmonic function. Any function that satisfies Laplace equation. Laplace equation means dou square phi by dou x square plus dou square phi by dou y square is equal to 0. Write down a function phi which satisfies Laplace equation, that is dou square phi by dou x square plus dou square phi by dou y square is equal to 0, is called harmonic function. Students, one student complaining, every student is unmuted. Please mute yourself. Please mute yourself. A small request to everybody. Please mute yourself. We'll discuss if you have doubts at the end of the session. Every student, please mute yourself. Note. Write down. If f of z is equal to u plus iv is analytic, then suppose f of z is equal to u plus iv is an analytic function, then we can show f dash of z is equal to dou u by dou x plus I into dou v by dou x. We can prove this. It is a theorem statement. F dash of z is equal to dou u by dou x plus I into dou v by dou x. That we can prove if f of z is equal to u plus iv is an analytic function. Next. Remember, everyone, real and imaginary parts of the analytic function will satisfy Laplace equation. That is u and v satisfy Laplace equation. Everyone remember, suppose f of z is equal to u plus iv is an analytic function, then u and v will satisfy Laplace equation. U satisfies Laplace equation means dou square u by dou x square plus dou square u by dou y square is equal to 0. Similarly, dou square v by dou x square plus dou square v by dou y square is equal to 0. And everyone should remember, any function that satisfies Laplace equation, that is called harmonic function. U and v satisfy Laplace equation, so u and v are called harmonic conjugate functions. U and v are called harmonic conjugate. Conjugate means you should not confuse. Conjugate means z bar. It is not like that of z bar. U and v are harmonic conjugate functions of each other. Means u and v satisfy Laplace equation. U and v are harmonic conjugate functions of each other. Next. Means simply harmonic functions. And everyone please remember, if f of z is equal to u plus iv is an analytic function, then the real and imaginary parts of the analytic function cut each other perpendicularly. All are theorem statements. Angle between real and imaginary parts of the analytic function is 90 degrees. Write down the real and imaginary parts u of xy is equal to c1 and v of xy is equal to c2 cut each other orthogonally. I have already given CR equations in Cartesian form. So CR equations in polar form. CR equations in polar form. That is dou u by dou r is equal to 1 by r into dou v by dou theta. U suffix r dou u by dou r, v suffix theta dou v by dou theta. Dou u by dou theta is equal to minus r into dou v by dou r. U suffix theta means dou u by dou theta. V suffix r means dou v by dou r. These are the Cauchy-Riemann equations in polar form. Next. If you want, and look here, dou u by dou x plus I into dou v by dou x. Suppose this is dou u by dou x plus I into dou v by dou x. According to CR equations, you can write Vx as minus dou u by dou y, or ux as dou v by dou y. That we can modify. Write down model number 1. Construction of model number 1, construction of analytic function Milne-Thomson method. Construction of analytic function Milne-Thomson method. See, construction of analytic function means, suppose f of z is equal to u plus iv is an analytic function. You are given only real part u. Without finding the imaginary part v, directly we need to find u plus iv completely in terms of z. Or suppose you are given only imaginary part v, without finding the real part u separately, we need to find f of z is equal to u plus iv completely in terms of z. That is model number 1. Write down, given f of z is equal to u plus iv is an analytic function. Suppose the real part u is given. Suppose the real part u is given, then to find f of z is equal to u plus iv in terms of z. We proceed as follows. You are given only the real part u. Then instead of finding v separately, we need to find u plus iv completely in terms of z. This is the way. And all of you remember this formula. Everyone remember this formula. If f of z is equal to u plus iv is analytic function, then condition number 1, we can show f dash of z is equal to dou u by dou x plus I into dou v by dou x. I can use this formula to get the required answer. Consider f dash of z is equal to dou u by dou x plus I into dou v by dou x. But there is a restriction. Look here, you are given only real part u. You are given only the real part u. That means you don't know what is the imaginary part v. You don't know what is the imaginary part v. You are given only real part u. That's why write v of x, v suffix x value in terms of u using CR equations. According to CR equations, we have dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. Multiply both sides of this second equation by minus symbol. So it is minus into dou u by dou y is equal to minus into minus plus dou v by dou x. The last one. So from this, f prime z means f dash of z is equal to dou u by dou x, vx value minus uy, plus I into minus uy, that is minus I uy. This is equation number 1. Next, put x is equal to z and y is equal to 0 in equation number 1. Listen to me. Actually, substituting x is equal to z, y is equal to 0 is not an assumption. Actually, we are discussing Milne-Thomson method. Milne-Thomson method, key points only I am giving. I am not deriving the definition. I am not deriving the theorem. By deriving this, we get x is equal to z, y is equal to 0. The only key points I am giving. After deriving using Milne-Thomson method, we are able to show x, z, y, 0. Directly I am saying that. See here, here u suffix x, u suffix y means dou u by dou x, dou u by dou y will contain x and y terms only. Dou u by dou x, dou u by dou y of equation number 1 will contain x and y terms only. When you take x is equal to z, y is equal to 0, in dou u by dou x and dou u by dou y, that is completely becoming in terms of z. Dou u by dou x, dou u by dou y will have x and y, xz, y0. Therefore, equation number 1 will be converted in terms of z. Let it be g of z. To get f of z value, integrating both sides. Integrating both sides. That is integral f dash of z dz is equal to integral g of z dz. Integration of f dash of z dz, that is f of z. Integration of f of z dz, that is f of z, integral g of z dz. Integration completed, add some constant. Same story if the imaginary part v is given. Similarly, f of z can be determined if the imaginary part v is given. I will teach one problem, followed by I will take the doubt session. One problem. Problem number 1. Given f of z is equal to u plus iv is an analytic function, if the imaginary part what happened? Raised hand. Please unmute yourself. See problems now. Yes, one by one. Let me teach this problem. If the imaginary part is given by e power x into y cos y plus x sin y. Then f of z is So imaginary part v is equal to e to the power of x into y cos y plus x sin y. V is equal to e power x into y cos y plus x e power x sin y. Find dou v by dou x. Dou v by dou x, e power x derivative, e power x only, y cos y as it is. Here x into e power x derivative, uv rule, ux v derivative e power x plus e power x into x derivative 1 u into v. This is u, this is v. U v derivative plus v u derivative, x derivative 1 into sin y as it is. Similarly, dou v by dou y, e power x into uv rule. This is u, this is v. U into v derivative, y into cos y derivative minus sin y plus cos y into y derivative 1 plus x e power x into sin y derivative cos y. In the exam point of view, directly you can take y0 xz here, or else write the formula. F dash of z is equal to dou u by dou x plus I into dou v by dou x. But we were given v only, so we can find dou u by dou v by dou x, dou v by dou y. That's why using CR equations, write ux value in terms of v. Write ux value in terms of v, since we are given only v. Dou u by dou x is dou v by dou y plus I into dou v by dou x. By CR equations, just 2 minutes, it will be completed. F dash of z is equal to vy. Vy is e power x into minus y sin y plus cos y plus x e power x cos y. This is v suffix y plus I into v suffix x. V suffix x is e to the power of x y cos y plus x e power x plus e power x sin y. This is step 1. Step 2 is substitute x is equal to z and y is equal to 0. Take x is equal to z and y is equal to 0. If I take y is equal to 0, this term 0. If I take y is equal to 0, this is cos 0, 1. If I take y is equal to 0, it is cos 0, 1. If I take y is equal to 0, this is 0. If I take y is equal to 0, sin 0, 0, 0 into something 0. Then the above equation becomes f dash of z is equal to 0 plus 1. 1 into e power x, that is e power z, plus x into z into e power z, plus z e power z. Rest of the terms being zeros. Z into e power z into 1. I can write z plus 1 into e power z. To get f of z value, integrate both sides. To get f of z value, integrate both sides. Remember, it should be integrated by using UV rule or by parts method. But another technique is also there. Instead of using by parts method or UV rule, I can use this technique also. But this technique is applicable only when the first term is a polynomial. I'm teaching a technique which is an alternate of UV rule or by parts method, but the technique is applicable only when the first term is a polynomial, second term is e power z, e power minus z, sin z, cos z. Then only, of course, sin hz, cos hz also. We can apply the technique. What is the technique? First term is a polynomial, means variable power non-negative integer. Second term is sin z, cos z, sin hz, cos hz, e power z, e power minus z. Then we can apply the technique. I'll write in the next slide. Just 2 minutes completed. The technique is in the margin of your notebook, write like this: differentiation, here integration. Write the first term as it is. Write the first term as it is here. First term means polynomial. Write the second term as it is here. Differentiate the first term step by step only until we get 0. Differentiate the first term step by step only until we get 0. Z plus 1 derivative 1, 1 derivative 0. Write the second term as it is here. Its integration here. Its integration here. Its integration here. Now start from positive sign. It is compulsory to start from positive sign. Go on continuously by alternately keeping the signs of plus, minus, plus, plus, minus, plus, minus, so on. The value of this integral is plus into these two terms product, plus into these two terms product, minus into these two terms product, this plus into these two terms product, 0 into anything 0. So that's why I did not write anything here. Actually, this is e power z. This integration value here. And now integral f dash of z dz. Let it be equation number 1. Equation number 1 implies that integral f dash of z dz is f of z. Integration of z plus 1 into e power z is plus into these two terms product, minus into these two terms product, plus into these two terms product, plus into z plus 1 into e power z, minus 1 into e power z, plus 0 into something 0. Integration completed, add some constant. Therefore, f of z is equal to z into e power z. Z into e power z plus 1 into e power z minus e power z cancel. This is the answer. Now I'll talk to each and every student in the sequential order. Sequence only. First, here Dhruv Bharat. Dhruv Bharat, Bharat. Please. Dhruv Bharat, please unmute and talk. Dhruv Bharat, unmute and talk to me.
Hello,
Tell me.
sir. I have a doubt in this function. This last sum,
Which one?
the last second sum, the previous last second sum, sir.
Okay. The previous one or this one?
Yes, yes, sir.
Tell me.
Sir, here how you have? Sorry, sir. This was not the sum, sir. Before this one, sir.
Before this, we don't have.
Okay, sir. So this sum only. Sorry, sir.
Tell me, what is the doubt regarding this?
Sir, in this sum, how you have taken that, sir? U was not given, and you have taken that V
Here,
V or
listen to
Vy.
me. Listen to me. F of z is equal to u plus iv is analytic function they mentioned. Okay, na?
Yes, sir.
Next,
Yes.
what they said, if the imaginary part is given by, see, f of z is equal to u plus iv. U is real
Yes.
part, v is imaginary part. If
Yes,
the
sir.
imaginary part is given by means v, remember f of z is equal to u plus iv is analytic function. Right? U is the real
Yes, sir.
part, v is the imaginary part.
Yes, sir.
They said imaginary part is given by, means v is given by. Okay, na?
Yes, sir.
Ah.
V.
Is it clear? Real part
Yes,
is
sir.
real part is given by means u, imaginary part is given by means v. Because the
Yes, sir.
function we have already assumed f of z is equal to u plus iv.
Yes. So, sir, you have differentiated with respect to x and y. This V imaginary part.
This is a dou v by dou x. V derivative
Yes.
with respect to x partially. Here v derivative with respect to y partially.
Yes. Then by that CR equations, okay. So by CR equation, this was satisfy ux equal to Vy.
Ah.
Well, you have del u by del
Actually,
x.
we are given only v. So that's why let us write ux value in terms of v using CR equations.
Yes, sir.
Is it
Yes,
okay
sir.
now?
Thank you, sir.
Okay,
Yes, sir.
please
Thank you, sir.
mute yourself.
Yes, sir.
Next,
Hello, sir.
Bhavani, are you talking?
Yes, sir. Sir, open the page number 39, sir.
Okay, fine.
So explain the starting, sir. Like, why did you went for CR equations? We need to check first analytic equation, right, sir?
Listen to me. First of all, before going to confirm whether one function that is either a differentiable or analytic, first to verify CR equations. CR equations are not satisfied, then that function cannot be differentiable, cannot be analytic. I have dictated points also.
Yes, sir.
See, if CR equations are not satisfied at any point, then the function will not be differentiable and hence not analytic at that point.
Okay.
That's why first to find the CR equation. CR equations not satisfied, it is nowhere differentiable and hence it is not analytic also.
Okay, sir. Thank you, sir. That was my doubt.
Okay. Thank you. Next.
Hello, sir. Sir, if CR equation is satisfied and
You are talking Shraddha, na?
yes, sir. Yes, sir.
Tell me, Amma.
Sir, if CR equation is satisfied, then it is compulsory that it is analytic and differentiable both.
No. Listen to me. If CR equations are satisfied, we cannot say it is analytic.
Okay.
Reason. Listen to me.
Yes, sir. Yes,
Just
sir.
1 minute. These two conditions are satisfied. Sufficient. Sufficient means enough. If these two conditions together are satisfied, both sufficient conditions, first one and second one, CR equations are satisfied, plus ux, uy, vx, vy, continuous function. Every constant is a polynomial. Any variable power non-negative integer is a polynomial. Every polynomial is continuous everywhere, differentiable everywhere.
Okay.
So if these two conditions are satisfied together, then it is analytic. Only CR equations are satisfied, it cannot be analytic. CR equations are necessary for any function to be analytic, but not enough, but not sufficient to prove it as analytic.
Okay, sir.
These two are sufficient to prove it as analytic. Is it clear?
Yes, sir. You teach excellent, sir.
Thank you.
Yes.
Please mute. Next, Satya Prakash.
Hello, sir.
Unmute Satya Prakash and tell me.
Hello, sir.
Tell me.
Sir, slide 21F, sir.
Slide 21. Tell me.
Sir, not this one, sir. Actually, before this one, sir.
Okay.
This
fine.
question.
Okay, no issue. This one,
yes, sir. This one. Sir, can you give us the how the equations of option C and option D look like?
See, confocal ellipses means different ellipses, set of ellipses with common foci. You can see in Google, you will see the confocal ellipses, set of diagram, set of ellipses with common foci.
Okay.
Similarly, confocal hyperbolas also.
Okay, sir.
All these ellipses with common foci they will have. For visualization, I cannot show here. It will take a lot of time to draw. Just enter what are confocal ellipses in Google. It will show you.
Yeah, sir. Okay. Thank you, sir.
Other?
No, sir. Thank you.
Okay. Please. In the sequential order, please unmute Mr. Satya Prakash. Next. Bhavani, do you have doubts? Bhavani.
No, sir. Akanksha.
Please mute yourself. Aksha.
Akanksha.
Sorry, Akanksha.
Yes, sir.
Akanksha.
Yes, sir. Audible?
You have any doubt?
Yes, sir. I have.
Tell me.
Sir, in entire function, you gave some of the examples. In those examples, there was polynomial also.
Yes.
And you said that entire function means that it will be analytic everywhere.
Entire function means analytic at all points except infinity. What is the doubt?
So then in some of the question we get that we get polynomial.
Which one?
So like question 1 after Cauchy's Riemann equation, question 1 itself.
Tell me.
So in this we are getting ux, uy all are polynomial.
Which one? This one, Anna?
Yes, sir.
Tell me.
So here all ux, uy and all are polynomial.
Yes. Your doubt is correct and ask me little bit loud. Ux, uy, vx, vy are polynomials. Why they are not entire?
Yes, sir.
Listen to me carefully. I said their polynomial is entire function, but it should be a complex polynomial. We are talking about complex numbers. So it is a complex polynomial. Complex polynomial means z power non-negative integer, not x or y. It should be a complex polynomial means z power non-negative integer is a complex polynomial that is analytic everywhere. So here ux, uy, vx, vy are real polynomials which are continuous everywhere, differentiable everywhere, but we cannot say which are analytic everywhere.
Okay, so it means that in question if fz is equal to given some polynomial z power some
suppose
positive.
f of z is equal to x square plus I into y cube, we cannot say it is an entire function. Suppose f of z is equal to z square plus z cube plus z power 4, which is complex polynomial, which is analytic everywhere.
Okay, sir. So
next.
Sir, yes, sir. Sir, here you said in the starting itself, you said theta is called amplitude or argument. Right?
Yes. Tell me, Amma.
So what is r then? What we call r? Radius.
R is called radius vector. This is just like right angle triangle. So y by x is equal to tan theta, opposite side by adjacent side. This is root of x square plus y square. This is radius.
Okay, sir. Sir, one more last doubt. If a function is differentiable, then it will be continuous?
Every differentiable function by default continuous. Listen to me, a differentiable function means suppose you are able to make a move. Suppose you are able to make a move at any point, then it should be differentiable at that point. Suppose you are able to move at some particular point means at that point the road is a continuous road, the path is a continuous path, correct or not?
Yes, sir.
So every differentiable function by default continuous everywhere.
Okay, sir. Sir, and in analytic, the point and the neighborhood point all should be analytic now.
See, analytic function at one point means function must be differentiable at that point, and a function must also be differentiable in the neighborhood of that point.
Okay, so in some options it's given analytic at 0,0.
Analytic comma 0 means I gave two sufficient conditions. No, did you remember sufficient conditions?
Yes, sir.
Listen to me. Analytic at 0,0 means, look, these two conditions must be satisfied at 0,0, and these two conditions must also be satisfied in some neighborhood of 0,0. Some neighborhood means let it be radius should be 1 or 0.5, like that. Neighborhood points means 0.2, 0.3. You need to check at all neighborhoods of at all points in the neighborhood of 0, 0, like 0.1, 0.2, 0.3, 0.4. It should be, if these two conditions satisfied at all those points in the neighborhood, then it is said to be analytic everywhere.
Yes, sir.
Sorry, analytic at that point.
Yeah. So why not analytic everywhere? Then it is when it is analytic.
1 minute, Amma. Analytic everywhere means these two conditions are satisfied at all points on the xy plane except infinity.
Okay, means if it will satisfy only at 0,0, then sir, I'm not getting.
These two conditions are satisfied only at 0,0. It is differentiable at 0,0 only. These two conditions are satisfied at 0,0, plus these two conditions are also satisfied in the small neighborhood of 0, 0. Small neighborhood of 0, 0 is 0.1, 0.2, 0.3, 0.3, like that.
Okay.
Then it is analytic at 0, 0. These two conditions are satisfied at all points, 1, 1, 2, 2, 100, 100, 1000, 1000, everywhere. It is analytic everywhere. That is entire function.
Okay, okay, sir. Thank you so much, sir.
Welcome.
Thank you.
Next, please mute yourself. Next, Bhavani. Next, Roshan Agarwal.
Hello, good evening, sir.
Good evening. Tell me.
Sir, I had a minor doubt. Means like you told no general value of theta is theta plus 2 and pi. Sir, I just wanted to ask, means like n equals 2, you told plus minus 1, plus minus 2. Sir, minus value when we will take? Sir, that I could not get.
See, n is equal to, suppose theta value, not here. Suppose theta value, look there. Suppose theta is equal to 2 pi. Okay, na?
Okay,
look
sir.
Here. Mr. Roshan Agarwal.
Yes, sir.
Are you looking the slide number 7F? Is it visible
Yes,
on the
sir.
screen?
Yes, sir.
Suppose theta value 2n theta plus 2n pi. What is theta value I assumed here?
2 pi.
2 pi plus 2n pi, right?
Okay.
Take n is equal to minus 1.
Okay, then it will become 0.
0. Take cos 0 plus I sin 0. How much it is?
It's 1.
You understand?
Okay, sir. Okay.
Is it clear, Mr. Roshan Agarwal?
Yes, sir. Yes, sir. But sir, I just wanted to know, means like you told no for cube root if it is asked, or to the power 4, or like square root, you told take 1 and then 2 and then 3. Sir,
1 minute. So, that is powers of the root. This is different. That is different. Suppose you want to find I power 1 by 4, fourth roots of 5. You
Yes,
can write in the you can write in this format only. You can write the way you can write in this format. Suppose you want to find I power 4, I power 1 by 4, 0 plus I into like this. Like this you write. 0 plus I into 1 whole power 1 by 4.
Yes,
R e power I theta whole power 1 by 2. Here, what is theta value? Suppose first theta value. Suppose you want 4 roots. First
Yes.
theta value minus pi by 2.
Yes,
Then
sir.
what is the solution? Theta plus 2n pi. Correct?
Yes, sir. Yes, sir.
Theta plus 2n pi. First root minus pi by 2 plus 2n pi. To get the next root, already n is equal to 0. First root minus pi by 2. Take n is equal to 1. You will get next root minus pi by 2 plus 2 pi. Take theta is equal to minus pi by 2 plus 2 pi. That is 3 pi by 2.
Yes, sir.
Now in place of this theta, take 3 pi by 2.
Yes, sir.
Suppose take n is equal to 2. To get the third root, take n is equal to 2. That is 4 pi. 8 pi minus pi, 7 pi by 2. By giving different n values, first n0, that is minus pi by 2. N is equal to 1, next root. N is equal to 2. That is for the roots. That is for the roots. It is the solution only.
Then, sir, n is equals to minus 1. If we take there, then it will give minus 3 pi, minus 5 pi by 2, sir. Then
That's why I'm saying whenever you want to find the roots of the equation, you have to take the sequential order only. N is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. I'm saying other than roots. Other than roots means what? Here
Just
we are
argument.
finding. Here we are not finding roots. Only one value. One value will not change by taking theta as theta plus 2n pi.
Okay. Got it, sir. Got it, sir.
Okay.
Thank you, sir. Thank you.
Please mute yourself.
Sir,
Next, tell me, Amma.
sir, in the last model which you have explained, like,
Tell me.
sir, in that you have taken x is equals to z and y is equals to 0 when you gave u as, means when you gave u.
You are given imaginary part. Imaginary part denoted by v. So we need to find f of z without finding the real part u.
Yes, sir, I understood that, but you have in the model which you have explained, that is model 1.
Yes. What is
In that
model
you
2
have
now?
taken, in that you have taken x is equals to z and y is equals to 0, no, sir. We have to put those values in that variable.
Okay, that is not an assumption. We have a simple derivation. If you want, I will send you that derivation to your mobile number. I gave my mobile number while I was teaching linear algebra. If you want, I will send that, how it comes. It's not an assumption.
Okay, sir. Thank you, sir.
If you want, tomorrow I'll share that, right?
Okay, sir.
Hello, sir.
Tell me.
Sir, in page number 42, sir.
Page number 42. Fine.
Yes, sir. In this question, sir, we said that CR equation nowhere satisfied, but in sir question number 1, 3-4 pages back, we why are we saying?
Let me go. Question number 1.
Yes, sir. Sir, basically.
Tell me. Here CR equations also nowhere satisfied.
Yes, sir.
1 minute. Listen to me. First, let me go here. CR equations not satisfied.
Yes, sir.
Sorry. In which number, which problem I said CR equations nowhere satisfied?
42. Page number 42.
42. Look here. Whenever directed at that time the screen was freezed, that's why you couldn't understand. Whenever direct CR equations are not satisfied, means ux directly not equal to vy. Correct?
Yes, sir.
Whenever direct CR equations not satisfied, then we need to check CR equations at the points. At which points? Whatever the points we need, whatever the options they mention, at those points you need to check CR equations.
Okay. Now I get it. Now I get it.
Here CR equations not satisfied. Then you need to check at the options. What are option points are
0,
0, 0. But if I want to substitute x0, y0, there is no x value, there is no y value in ux, uy, vx, vy. So how can we substitute?
Any value. Yes, sir. Now I get it. Basically, if CR equation is not satisfied, then we go to the point and then we check
at
the
which points it is impossible to check each and every point.
Yes, sir.
Whatever the points they mentioned in the options, no, at those points we need to check.
Okay, and then that uske baad, sir, we check the neighborhood points for the analytic.
Suppose they gave 1, 1. Suppose CR equations are satisfied at 1, 1. Then you need to check CR equations in the neighborhood of 1, 1, like 1.1, 1.2, like that. But one thing, generally one function that is becoming at 1 point, all the type of functions by default analytic everywhere.
Okay, sir.
So we don't have a function to be analytic at 1 point practically.
Okay, sir. Sir, also, sir, one thing. Sir, I don't have your number. Can I get your number? And sir, I would also want to know your name, sir.
My name is Venkat Rao. This is my mobile number.
Okay, sir. Thank you, sir. Thank
Next. Welcome. Next.
Hello, sir.
Tell me.
Sir, my doubt is in the argument, sir. Sir, here you have said that theta value lies only between minus pi to pi, no, sir?
Only principal value.
Sir, means we should not include minus pi, sir.
We should not include. Reason, you will always get theta value between minus pi and plus pi, including plus pi also. If you have a doubt, any complex number you take, I have already given. This is theta is equal to 0. What is this? Look, reason I will tell you. What are the values between these two? 0 and pi by 2. Correct?
Yes, sir.
Same values in the opposite quadrant should be between 0 and minus pi by 2. Correct?
Okay, sir.
What are the values between these two? Second and third, these two.
135, sir.
90 and 180, yeah?
Yes, sir.
Same values in opposite quadrant should be minus 90 and minus 180 only, no?
Oh, okay, sir. That's why I was thinking, sir, in a problem we got 3 pi by 2. I was thinking that it is out of range. I was thinking, sir.
3 pi by 2, 1 minute. You are saying 3 pi by 2. This is 70.
So it
this
is
is
minus
3 pi
9.
by 2, right? This is 3 pi by 2, but it is pi by 2, no? This is pi by 2. So this is minus pi by 2 you need to take.
Oh, okay, sir. Sir, means they are saying minus pi to pi, but it is covering like overall 4 quadrants.
Yes, overall 4 quadrants. Because reason I will let you know. Suppose you take one complex number.
Okay, sir.
2 minus I. Any complex number will lie in these 4 quadrants. All these 4 quadrants values are lying between the values I said.
Yes, sir.
That's why I said principal value, not general value. Principal value means your theta value between minus pi and plus pi. General value means theta plus 2n pi.
Oh, sir, theta means which we calculate first theta which we get.
First theta which we get, the corresponding quadrant theta. In which quadrant your complex number lies, that quadrant theta value you need to write.
Okay, sir. Means if we take first and second quadrant, it is from 0 to positive pi. If we take third and fourth quadrant, it is from 0 to minus pi.
That's it.
Okay, sir. It's now clear, sir.
Okay.
Thank you, sir.
Welcome. Next.
Good evening, sir.
Good evening, Amma. Tell me.
For me, it's page number 15, yeah.
15, Amma?
Yes, sir. 15.
Tell me, Amma.
Sir, in this, why we took that tan inverse of infinity minus pi by 2, sir? Because...
this is, look at here, this is minus 1 by 0, na?
Yes, sir.
Minus 1 by 0 is minus infinity, yeah?
Yes, sir.
And moreover, tan inverse of minus x is equal to minus tan inverse x.
That's okay, sir. But in this next problem, we didn't took the minus out, sir. Root 3 We
This you understood that tan inverse of minus infinity is equal to minus into tan inverse infinity. Okay, na?
yes, sir. Taking out is I understood.
Which problem? This one?
Next one.
This one.
In this we didn't.
Reason I will let you know, ma. Reason I will let you know.
Okay.
Look here. What I said earlier, I'll clarify the doubt.
Okay.
And look here, what I said here. Look here, theta value should lie between
Plus
minus pi and plus pi.
minus, yes.
Before you also, I taught the same to the student. Theta value should lie between minus pi and plus pi. Correct?
Yes, sir.
Including plus pi. Now, quadrant is important. And look here. And look here. X coordinate 0, Y coordinate minus 1. X coordinate 0, Y coordinate minus 1. Where it lies?
Third.
Look here. Look here, Amma. X coordinate 0, Y coordinate minus pi, Y coordinate minus 1. That lies here only, no?
Yes, sir. Yes, sir.
What is this line I said? Look the diagram I gave. Where is the diagram I gave? What is this line I said? Theta is equal to 3 pi by 2. This is theta is equal to 0. Theta is equal to pi by 2. Theta is equal to 180. Theta is equal to 270. Theta is equal to 360. You understand?
Yes, sir.
Yes, sir.
This is theta is equal to pi by 2. This is theta is equal to 3 pi by 2. This is theta is equal to pi by 2. Theta is equal to pi by 2. Exact opposite. Theta is equal to minus pi by 2 also, no?
Yes, sir.
So your theta value should lie between minus pi and plus pi, no?
Yes, sir.
So here, actually, where is that?
15F.
15. If you take, if you actually, your doubt is tan inverse of minus infinity, that would be 3 pi by 2 because it is lying in the third quadrant. Correct or not?
Yes, sir.
But theta restriction principal value should lie between minus pi and plus pi. Correct or not?
Yes, sir.
This is theta is equal to 3 pi by 2. If theta has to lie between minus pi and plus pi, this is also taken as minus pi by 2, no? Is it clear?
Hello, sir.
Yes, sir. Understand.
Hello.
Sir.
1 minute.
Hello, sir.
Did you understand, Amma?
Yes, sir. Understood, sir. And
Achika?
sir, homework you gave third problem, sir. Homework.
Page number.
Actually, page number I don't know, sir. Homework you gave 2 problems continuously, 3 and 4 homework.
Tell me.
In that, sir, for me it's not coming as analytic, sir, but it is also not differentiable, right, sir?
Not differentiable, not analytic. Correct. I have written like that. Not differentiable. If it is not differentiable, then only it cannot be analytic. If it is not differentiable, then only it cannot be analytic.
Okay, sir. So
This
you
is
gave
not
the answer is
differentiable.
not analytic, but it's also not differentiable. That's right.
Yes, not differentiable. Not differentiable means by default not analytic.
Okay, sir. And
Hello, sir.
32F, sir. 32F.
Page number?
32F. 32.
Fine. Chepamma.
In
Tell
this, sir, if some problems gives condition as ux equal to minus vy and uy equal to plus vx, is it acceptable, sir?
No, whatever I gave, which are only acceptable. Other than that, in any form they give, it is not at all true.
Okay, sir. Sometimes the minus is changed one, so I got confused that one.
No. Only you have to remember like that only, whatever I give. Other than that, anything satisfied, that is not true.
Okay, sir. Thank you, sir. That's it.
Hello, sir. Hello, sir.
Tell me.
Hello, sir.
Tell me, audible.
I missed a harmonic topic, sir. Harmonic functions. Once again.
Harmonic function means any function that satisfies Laplace.
Once open, sir. That one I didn't write. I didn't take a screenshot. Harmonic function.
This one.
Harmonic function definition and.
At first to take this, I will next.
I have taken this. This. Tell me, sir.
This one.
Hello. Yes, sir.
Have you taken?
Next what is there, sir? Next page.
After harmonic function, this is the next slide.
Okay.
Have you taken?
Yes.
This is the next slide.
Okay. Can you tell me?
Taken?
Take it.
Next, this is.
Tell sir once. What is a harmonic function?
Okay, na?
Hello, sir.
Tell me.
Hello.
Sir. Hello.
One person.
Hello.
Tell me.
Tell me harmonic function. What is harmonic function?
Harmonic function means any function that satisfies Laplace equation. Laplace equation means dou square u by dou x square plus dou square u by dou y square is equal to 0. Then u is called harmonic function.
Okay.
If u replaced by phi is called harmonic function.
Okay.
Sir.
Hello, sir.
Hello, sir.
Next.
Sir, tell me.
Tell me.
I'm listening, sir. Tell me. Next slide in this. After harmonic, this note is there, not one.
Suppose f of z is equal to u plus iv is analytic function. Then real and imaginary parts u and v satisfy Laplace equation.
Okay.
If u plus iv analytic, u and v will satisfy Laplace equation. U satisfies Laplace equation means dou square u by dou x square plus dou square u by dou y square is equal to 0. Similarly, v satisfies Laplace equation means dou square v by dou x square plus dou square v by dou y square is equal to 0.
Okay. It is satisfied this condition we are taking for harmonic functions.
U and v are called harmonic functions because u and v satisfying Laplace equation. No, that's why u and v are called harmonic functions.
Okay.
Suppose u, if u plus iv analytic function, then u and v cut each other orthogonally. Means the angle between real and imaginary parts of the analytic function is 90 degrees. That is fourth condition.
90 degrees.
Hello, sir.
Really, sir, can you open
Next page, sir. Sir, next slide. Hello. Next slide.
This one.
Tell me this one also, sir.
I have already taught in the class, no?
Today is my first class, sir.
This is first class only, mine also.
I have missed this, sir, because of some internet connection issue.
Can you wait for some time because the others?
Next slide. I will take a screenshot and.
Sir.
Next.
1 minute. Okay, na? Wait for 2 minutes. Other students' small doubts are there. I'll clarify and I'll explain this.
Okay.
Hello, sir.
Hello, sir.
Tell me.
Has
One by
in
one.
polar form of a complex number, sir. Can you please open that page?
Page number?
Sir, starting, I think, basic definitions. There was one definition that you told I didn't get it. That.
This one definition, introduction.
Then theta, polar form.
This one.
Under the polar form.
This one.
Yeah, next page. Yes, sir. In here, we are saying that if theta is between minus pi to pi, then theta is called principal value of argument z. But theta is itself, it's called argument of z. So how are we saying this?
Argument of a complex number means, see here, theta. Actually, theta is equal to tan inverse y by x is called amplitude. Amplitude means what? Do you know? Maximum height, amplitude.
Yes, sir.
That amplitude is called argument. What is the maximum height of the amplitude? This one only, no?
Yes, sir.
Theta is equal to y by x is called amplitude or argument. It is called argument of a number.
So, but then theta is called principal value of argument of z. Theta is called itself. What does that mean?
Suppose this tan inverse y by x value should
Yes,
lie
sir.
between my tan inverse y by x means theta. Tan inverse y by x value, if it lies between minus pi and plus pi, then that tan inverse y is called principal value of argument of z. Tan inverse y by x means theta.
Okay, if it's lying, we are applying a condition here, and that's why we are saying it's called.
We are not applying any condition, Amma. Already the same thing I have taught before 2 persons. Theta value always lies between minus pi and plus pi. Look at the diagram. See here, first quadrant range 0 to 90. Yeah?
Sure.
Opposite quadrant minus pi by 2 to 0. Fourth quadrant, correct or not?
Yes, sir.
Second quadrant range 90 to 180. Correct?
Yes, sir.
Opposite quadrant, third quadrant range minus pi by 2 to 0.
Yes, sir.
And then it is always lying between minus pi and plus pi only, no?
Yes, sir.
You didn't get, please ask me correctly.
So, but theta is itself called argument of z, right?
Theta itself is called argument of z.
So what does this sentence mean then? Then that argument of z is called principal value of argument of z. If we replace theta by
theta is called argument of, see, theta is called principal value. If theta value lies between minus pi and plus pi, then theta is called principal value of argument.
Okay.
Theta is argument of z only. Theta is called argument of z. If theta lies between minus pi and plus pi, then theta is called principal value of argument.
Okay, got it, sir. And in the last problem, that technique that we used to solve that integration, can you please explain that?
Tell me, what do you need from this?
That technique that we solved.
Okay. That technique you want?
Yes, sir. Yes, sir. This one.
Remember, suppose integral first term is a polynomial.
Yes, sir.
Polynomial means z power non-negative integer. Second term is e power z, e power minus z, sin z, sin hz, sin hz, sin hz, cos hz. In all such cases, we can apply the technique. What is the technique? In the margin of your notebook, write the first term as it is. First term means polynomial. Okay, na?
Yes, sir.
Second term, e power z, right here. This is a differentiation, this is integration. This is the first term should be differentiated step by step. First term should be differentiated step by step till we get 0. Z square derivative 2z, 2z derivative 2, 2 derivative 0. First term is differentiated step by step till we get 0. Now second term e power z, its integration value should be written here. Again e power z integration should be written here. Again e power z integration should be written here.
Yes, sir.
After completion of this process, start from positive sign. Start from positive sign, go on continuously by alternately changing the signs of plus, alternately minus, alternately plus, alternately minus. The value of this integral is
Z square Ez minus
plus
2z
into
Ez.
these two, minus into these two, plus into these two, minus into these two. This integration value is plus z square into e power z minus 2z e power z plus 2 into e power z plus 0 into something 0.
Okay, sir.
Is it clear, Amma?
Yes, sir. Yes, sir. Got it.
Hello, sir.
Hello, sir.
Sir, 20F.
So,
20
I have a
F.
small doubt, sir. After that, I will leave. So, thing is, in general calculus, we are saying that f of x equal to some value, and we are saying it is differentiable only when it is continuous. Is it similar like here we are taking z equal to u plus ix, so it is like similar. Is there any similarity?
I didn't get what you are asking clearly.
Sir, here we are telling an complex variable is differentiable only if it is analytic.
Yes.
In calculus also there is something similar, no sir? Like if it
Listen to me, differentiable at one point means in calculus it should be continuous at that point.
yes sir.
By
Similarly
default.
here also, like is there a similarity between these two?
Between
the complex variable and that calculus part.
Regarding which point? Analytic or differentiable?
Analytic and differentiable.
There differentiable means in calculus, differentiable means suppose it is a differentiable at this point means you have to check in the neighborhood. You have to check in the neighborhood of 2 only on x-axis. You have to check in the neighborhood of 2 only on x-axis.
Yes, sir.
But in complex variables, neighborhood of 2 means on the xy plane. Here neighborhood of 2 means this is neighborhood of 2 on only on x-axis neighborhood of 2.
Yes, sir. Yes,
means these points only. But in complex variables, neighborhood of 2 means all these, including these x-axis, y-axis, and these also.
Therefore, we can say that it's 2 axes. We are just checking 2 axes instead of 1
Complex
axis.
variable means what? X plus iy means
Yes, sir.
x-axis plus y-axis.
Axis. Okay, sir. So both are same. So I was just asking because it is easy to prepare if we.
Is it clear or not?
Yes, sir. It is clear, sir.
Next.
Sir,
Thank
sir,
you.
Sir, 20F.
entire function చెప్పారు కదా
20F.
20?
F. 20 page number.
Ah. Okay.
19, sir, I think.
Okay, fine.
Your problem, constellation of circles problem.
Ah.
Set up. Sir, you have solved this, no, sir?
Ah.
Same problem, I think.
Tell me. Yes, correct. I solved the same problem.
Sir, I didn't understand that method, sir.
See here, you are given what
yes.
you are given W is equal to ln z, right?
Yes, sir.
ln z. Z means what? X plus iy.
Yes, sir.
Are you getting what I'm saying?
Yes, sir. Getting, sir.
So x plus iy. Logarithm of x plus iy cannot be evaluated directly, right? That's why I'm converting into polar coordinates. In polar coordinates, x plus iy should be replaced by polar form of a complex number.
I got all this, sir. But why you substitute C and K?
1 minute. Which problem it is? Okay. What is the doubt regarding why I took?
An answer.
See, look, man. E means what? 2.718. Small e value 2.718. 2.718 power c is a constant, no?
Yes, sir.
So this e power c is a constant. I assumed that new constant as k.
Sir, in this already here given u is in question already has given u, no, sir. We have to find out v, no, sir.
No. See what we are asked to find. W is equal to ln z represents straight line or circle or confocal hyperbola or confocal ellipse. Did they ask to find v value? W
No,
is
sir,
equal to
here already given u, no, sir.
W is equal to ln z represents what? Logarithm of z represents what type of curve on the z plane?
Okay.
You are not asked to find v.
Okay, sir. Actually, I thought here already we are given constant lines for u. So we have to find v.
W is equal to ln z will represent what type of curve in the z plane as?
Sir, so what is the use of u giving constant line, sir?
See, W is equal to u is equal to constant. U is equal to 2. See, u is equal to constant means For example, y is equal to 2. Y is equal to 2 means what? Straight line parallel to x-axis.
Yes, sir.
So similarly, this is xy plane. UV plane means this is u, this is v. U is equal to 2 means a straight line parallel to v axis.
Okay.
Hello,
One
sir.
line, u is equal to 2 is one line and v is equal to some other function is a line.
Yes, sir.
If it is not constant, u may be given as xy. Xy is one curve. So you need to draw u is equal to xy curve on the x diagram, xy plane.
Here u is constant, so we are taking in the place of u c.
Yes, u is constant means in place of u we took c.
Okay, sir.
Is it
Got
clear?
it. Yes, sir. Got it, sir.
Okay.
Hello,
Next.
sir.
I have
Hello,
a
sir.
small
Sir.
16x.
Sir, you said. Hello, sir.
Tell me one by
Sir,
one.
you said the entire function, no, sir. Sir, entire function అంటే ఇప్పుడు ఆ టూ సఫిషియెంట్ కండిషన్స్ అనేవి ఎవ్రీ వాల్యూ దగ్గర సాటిస్ఫై చేస్తూనే ఎంటైర్ ఫంక్షన్ కదా సార్
Both sufficient conditions must be satisfied at all points except infinity on the xy plane, that is entire function.
సార్ ఇప్పుడు అవి సిఆర్ ఈక్వేషన్స్ కాకుండా నార్మల్ మెథడ్ లో చేయడానికి చాలా కష్టం కదా సార్ అది
Normal method, it will take lot of time. Only CR equations comfortable and convenient.
అంటే ఇప్పుడు ఒక నార్మల్ మెథడ్ అయితే ఇప్పుడు ఒక పాయింట్ దగ్గర అనలిటిక్ చెక్ చేసి మళ్ళీ ఆ కరెస్పాండింగ్ నైబర్హుడ్ లో మళ్ళీ చెక్ చేయాలి సార్ అది అంటే రిపీట్ లూప్
Finite number of points will be there, then how can you check at all those points?
సార్ దట్స్ వాట్ అంటే మీరు ఒక ఎగ్జాంపుల్ చెప్పారు 0.1 0.2 అట్లా అది ఇంపాసిబుల్ కదా సార్ ఇట్లా చెక్
అది
చేయడం
ఇంపాసిబుల్. అందుకే ప్రాక్టికల్లీ ఎనీ ఫంక్షన్ వీ డోంట్ హ్యావ్ ఎనీ ఫంక్షన్ దట్ ఈస్ టు బి అనలిటిక్ ఎట్ వన్ పాయింట్. If you find one function that is found to be analytic at one point, by default that function should be analytic everywhere practically.
Yes. Sir, another doubt, sir. Sir, n value ఇచ్చారు కదా సార్ మైనస్ n ఈక్వల్ టు 0 ప్లస్ ఆర్ మైనస్ 1 ప్లస్ ఆర్ మైనస్ 2 అది ఓన్లీ యాంగిల్స్ కే కదా సార్ అది అంటే రూట్స్ కి అయినప్పుడు ఓన్లీ పాజిటివ్ ఇంటిజర్స్ తీసుకోవాలి
ఓన్లీ nth రూట్స్ అంటే n is equal to 0 1 2 3 ఆ రూట్స్ ఆఫ్ ఏ నంబర్ అయితే అది ఆ రూట్స్ ఆఫ్ ఏ నంబర్ కాకుండా ఓన్లీ వాల్యూస్ అయితే n is equal to 0 ప్లస్ మైనస్ 1 ప్లస్ మైనస్ 2 తీసుకో.
ఓకే సార్ ఓకే గాట్ ఇట్ సార్
ఓన్లీ రూట్స్ 0 1 2 3
ఓన్లీ ఇప్పుడు థర్డ్ ఆర్డర్ ఓన్లీ థర్డ్ క్యూబ్ రూట్ అంటే ఓన్లీ n ఈక్వల్ 0 to 2 తీసుకో అంతే కదా
0 1 2 ఫోర్త్ వరకు అంటే 0 1 2 3 roots means 0 1 2 3 n minus 1. That's why I said up to n minus 1.
Okay sir, got it sir.
Okay, next.
Can you open 16?
1 1 6
and 6 yes sir. So sin 3 pi by 4 is minus 1 by root 2. Sin 3 pi by 4 it is minus 1 by root 2 sir.
Sin 3 pi by 4 ante 3 pi by 4 means 135 degrees.
Sir, minus cos 45.
One minute. Sin 135 should lie between 90 degrees and 180 degrees.
Yes sir.
90 degrees and 180 degrees means second quadrant.
Yes sir.
In the second quadrant, sine and cosecant are positive.
Sir, yes sir.
Correct?
Yes sir.
If you have a doubt, suppose you forgot, in the exam virtual calculator will be there. Pi value 3.14, 3 into 3.14 divided by 4. You find that. Find the sign of that value in terms of radians. That's it.
Sir, another doubt, sir. Usually, if a plus ib is a root, a minus ib is also the root of the same equation.
For polynomial equation, suppose your equation is a polynomial equation. If a plus ib is an eigenvalue, then its complex conjugate a minus ib is also another eigenvalue. That is valid only for the given equation to be a polynomial equation. For example, the characteristic equation of a matrix is a polynomial equation. So if a plus ib is an eigenvalue, a minus ib is also another eigenvalue. Similarly, in differential equations also, roots of auxiliary equation roots also a plus ib, a minus ib are the roots.
Sure.
That is valid only for roots for polynomial equations only.
Okay, sir.
Next, Amma.
Hello, sir.
Tell me.
Hello, sir. 21F.
21F.
Sir, in this C equal to L and RC, next step not on F. So R equal to E power minus E power.
Which one?
Third step R equal to E power C.
Okay. See here. This is ln R is equal to C. This is ln R to the base E. Ln R to the base E. R is equal to E power C. Are you diploma student?
Yes, sir.
Okay. Listen to me. Diploma students, they are weak. This is in 12th class trigonometry. In 12th class trigonometry, we had a rule. Look here. Ln x is equal to 2. X to the base E here. So x is equal to E to the power of. This E is there, no? This 2 will go power of E. X is equal to E power 2. X is equal to E power 2. We had a derivation. See here, ln x is equal to A. So this is ln x to the base A. So x is equal to E power A. This is not a formula. How it comes, we had.
Okay, sir.
Okay, na?
Sir, R square equal to K square.
Chepu. Tell me.
R square equal to K square. You take.
I took E power C is equal to K.
K means R square equal to K square. How it will be set of concentric circles.
Okay, good. What is K?
K is R radius.
K is constant, radius. K constant, that is not an ordinary constant. It is arbitrary constant. Arbitrary constant means that can be replaced by any real number between minus infinite and plus infinite. Suppose I take K is equal to 1, I will get one circle with radius 1. If I take K is equal to 2, I get another circle with radius 2. If I take K is equal to 3, I get another circle with radius 3. By giving different values to K, you will get different circles. All circles with the same center and different radii are called concentric circles. K is equal to 1, radius 1. K is equal to 2, radius 2 circle. K is equal to 3, radius 3 circle. Means we are getting different circles with different radii but same center. Correct or not?
Right, sir.
All circles with same center and different radii are called concentric circles.
Hello, sir.
Tell me, Amma.
Sir, 17F, sir. Sir, in the theta value, can you please explain, sir, once more?
Look here. Here, what is x coordinate?
-1, sir.
Y coordinate?
√3.
X coordinate -1, y coordinate √3. Means x coordinate negative, y coordinate positive in which quadrant?
Second quadrant, sir.
Second quadrant range?
Pi by 2 to minus pi.
No. First quadrant 0 to 90. Second quadrant 90 to 180. Correct?
Yes, sir.
So x coordinate -1, y coordinate √3, that lies in the second quadrant. Second quadrant range 90 to 180. Correct?
Yes, sir.
So what you need to think is between 90 degrees and 180 degrees, between 90 and 180, at which point your tan function should be -√3. Between 90 and 180, at which point your tan function should be -√3. Between 90 and 180, tell me tan 120. Tan 120 means what? Check from Calci. Take Check tan 120 in terms of radians, not in terms of degrees from Calci.
Okay, sir.
Is it clear, Amma?
Yes, sir. In like that.
You always have to assume that your quadrant lies in, your point will lie in which quadrant?
Okay.
Is
Sir,
it
but
clear?
mine 60. No, sir, tan 60 is root 3, no, sir. That is in
Tan
the
60
first
root
quadrant.
3, but it is in the first quadrant.
First quadrant. Okay, sir. Thank you.
Is it clear?
Yeah, sir.
You can cross check in the exam in virtual calculator. You can try tan 90 infinity, tan pi 0. So between tan 120, tan 120 minus 1.732, but all values in terms of radians only.
Okay, sir.
That's it, Amma.
Thank you.
Okay, well.
Sir, good evening.
Good evening. Tell me.
Sir, in page number 24. 24. 24. Sir, next page. Sir, ఇక్కడ k values and n values ఎలా తీసుకోవాలి సార్ ఒకవేళ సాల్వ్ చేసేటప్పుడు?
Suppose cube roots of 1 అనుకో.
Yes, sir.
Then how did you find these values? This is square roots of minus I.
Yes, sir.
This problem square root of minus I.
Yes, sir.
So you got theta value na?
Yes, sir.
Minus pi by 2 na?
Yes, sir. Minus pi.
Theta value minus pi by 2. Minus pi by 2, n is equal to 0, 1, 2. n is equal to 0, theta plus 0. Theta value minus pi by 2. Take n is equal to 1, theta plus 2 pi. Theta plus 2 pi means what? Minus pi by 2 plus 2 pi. Like that only you have to take.
No, sir. ఇక్కడ k values, n values, 2 values ఉన్నాయి కదా సార్ ఆ ఫార్ములాలో.
You don't take any n value. You have to take only k values.
So what about n సార్? ఇక్కడ ఫార్ములాలో n ఉంది కదండి సార్.
n ఉందంటే నీకు అర్థం కాల. నువ్వేం కనుక్కోవాలనుకున్నావు? క్యూబ్ రూట్స్ ఆఫ్ n, క్యూబ్ రూట్స్ ఆఫ్ 1 కనుక్కుందాం అనుకుంటున్నావా?
ఎస్ సార్.
n is equal to 3 అయిపోయింది కదా. r power 1/3 n is equal to 3 అయింది కదా.
సో n కాన్స్టెంట్ సార్? n 3 కనుక్కో, అప్పుడు n 3 పెట్టుకోవాలా సార్?
అలా కాదు, నువ్వేం కనుక్కుందాం. నీకు ఇంటర్మీడియట్ లో 10th ట్రిగ్నామెట్రీలో క్యూబ్ రూట్స్ ఆఫ్ యూనిటీ, ఫోర్త్ రూట్స్ ఆఫ్ యూనిటీ, nth రూట్స్ ఆఫ్ యూనిటీ అని కనుక్కున్నావా?
ఎస్ సార్.
క్యూబ్ రూట్స్ ఆఫ్ యూనిటీ అంటే ఏంటి? 1 పవర్ 1 బై క్యూబ్ రూట్ ఆఫ్ యూనిటీ అంటే x క్యూబ్ ఈజ్ ఈక్వల్ టు 1, x ఈజ్ ఈక్వల్ టు 1 పవర్ 1/3. అర్థమైందా? ఇక్కడ చూడు, 1 పవర్ 1/3 అంటే n ప్లేస్లో ఎంత ఉంది?
3.
అదే ఫిఫ్త్ రూట్స్ ఆఫ్ యూనిటీ అంటే z పవర్ 1/5 n ప్లేస్లో ఎంత ఉంది? 5. నిన్ను ఏం కనుక్కోమంటున్నాడో అది రాయాలి.
ఓకే సార్. k వాల్యూస్ మాత్రమే చేంజ్ చేసుకుంటూ వెళ్ళాలి సార్.
k వాల్యూసే. ఇక్కడ చూడు, అసలు యాక్చువల్గా దీన్ని అలా చేయొచ్చు. ఇది ఏంటి ప్రాబ్లం? ఇది స్క్వేర్ రూట్స్ ఆఫ్ మైనస్ i కదా. అంటే ఏంటి? అక్కడ 1/2 n ప్లేస్ లో 2 ఉంది, ఇక్కడ గుర్తుందా? ఐడియా వచ్చిందా?
వచ్చింది సార్.
ఓకే,
థ్యాంక్ యూ సార్.
ఓకే,
హలో సార్.
నెక్స్ట్.
హలో సార్. 37.
Ah.
37.
This is 37 only.
29. Sir, in this first you apply dou u by dou x. After we check CR equation.
First directly CR equations not satisfied. If CR equations are directly not satisfied, then you need to check CR equations at the options. What are option points? 0, 0. That's why I have verified direct CR equations not same. That's why I have verified.
In x and y, sir? 0, 0, x and y points, sir.
0, 0 and x coordinate 0, y coordinate 0. So here take x 0, y 0. Ux is equal to y 0. Uy is equal to x 0. Vx already 0. Vy is equal to 2y. 2y and y coordinate 0.
Sir, in this CR equation is satisfied means you take another polynomial, sir.
I didn't get what you are asking.
CR equations were satisfied, no, sir, first.
Where it is satisfied, please verify. This is ux, this is vy. Ux is equal to vy, yeah?
No, sir.
Then polynomial you are saying, CR equation satisfying you are saying. Ux, uy, vx, vy polynomials. Every polynomial is continuous everywhere. But ux, uy, vx, vy continuous everywhere. But ux, uy, vx, vy not satisfied CR equations. Whenever a direct CR equations are not satisfied, then we need to check our CR equation, set the options. Option points are 0, 0. Correct?
0, 0. Okay.
That's why I checked at 0, 0. I don't understand what you are asking still.
You checked 0, 0 after why you take polynomials.
One minute.
0.2.
First of all, you did not remember the concept. These two conditions are satisfied at one point. It is differentiable at that point. CR equations are satisfied at 0, 0. Na? I have clearly dictated notes also. CR both sufficient conditions are satisfied at one point. It is differentiable at that point.
Okay.
So these two conditions are satisfied at 0, 0. Therefore, it is differentiable at 0, 0. And ux, uy, vx, vy are continuous functions which are continuous everywhere because it is a polynomial which is continuous everywhere. So this condition satisfied everywhere. But another CR equations not satisfied everywhere. CR equations satisfied at 0, 0 only. But ux, uy, vx, vy continuous everywhere. Therefore, they are continuous at 0, 0 also.
Okay.
Did not understand?
Sir, understand, sir.
Okay.
Sir, last problem. 58. Previous page, sir. 56. Vy equal to 50. 55.
I didn't get what you are asking.
55 page number. In this Vy equal to last it's equal to
why is not clear?
Vy equal to how it is. Equation.
Ux is equal to Vy. CR equations. What are CR equations? Ux is equal to Vy. Uy is equal to minus Vx. They have already said the given function is analytic. So here we are given imaginary part. We are given imaginary part. Imaginary part means V. So are you getting?
Sir, Vy equal to how you take V power x minus you differentiate, no, sir.
This is u, Vy, e power, when you are differentiating with respect to y partially, other variable x is constant. So e power x constant, uv rule. This is u, this is v. Y into cos y derivative minus sin y plus cos y into y derivative 1. Is it clear?
Okay, sir. But you put x equal to z, y equal to 0. Why, sir?
That is an assumption. Actually, it is Milne-Thomson method. We had a derivation. I did not teach the derivation. I gave direct key points. We have a derivation. That's an assumption. So please remember it as an assumption. Look here, I said no. Here. Procedure xz y0.
Okay, sir.
I said xz y0.
Okay, sir. Thank you.
Is it clear?
Clear.
Next. Anybody else? Students, I am going to end the session.
Sir, can I say something?
Tell me.
Sir, can you please, while the session is going on, when you are teaching, can you please remove the raise hand option?
Tomorrow onwards, I'll be doing same.
Yes, sir. That thing only, yes, sir.
Tomorrow onwards, I'll be doing that.
Yes, sir.
Okay, na?
Yeah, that's just a suggestion, sir.
Fine.
Thank you, sir.
Okay.
Hello?
Tell me, Amma.
Sir, I have a small doubt that you have said the harmonic function now. After that, you given some note point.
Tell me, Amma.
Sir, is this both related? Means u and v must be harmonic function, then only we will write this formula f dash z is equal to ux plus I.
No. Actually, I said necessary and sufficient. Hello?
Yes, sir. Yes, sir.
I said a necessary and a sufficient condition for f of z is equal to u plus iv to be analytic, no? In that sufficient condition, there we need to prove the theorem. Initially, I said, did you remember?
Yes, sir. Yes, sir.
There, in the sufficient condition, we can prove the theorem. F dash of z is equal to ux plus I into vx.
Yes, sir. That means these both are not related now. We don't have to check the harmonic function, whether it is Laplace, satisfying Laplace equation or not.
No, it's not clear what I'm saying. Could you please ask once again? I mean clearly. What is your doubt, Amma? Akanksha?
Yes, sir.
What is the doubt?
So I just want to ask that you have given that harmonic function definition.
Yes.
And just after you given note.
Fine. From harmonic, if u and see 1 minute, if u plus iv analytic function, u and v are harmonic functions. From that we cannot show this ux plus I into vx.
Pardon, sir, what you want to say?
Suppose u plus iv is analytic function.
Yes, sir.
Then I proved ux plus I into vx as f dash of z. Then what is your doubt?
Sir, I just want to ask that you proved now f dash z is equal to ux plus iy.
That is a differentiation d by dz of f of z.
Yes, sir. Is there just any relation that why you
No,
taught
not
this
at all
harmonic
relation.
function?
No, not at all relation. That it's a derivation, not at all related. We cannot prove.
Oh, means you just informed that this is harmonic function, you just started some note.
Actually, why I gave harmonic function definition is, if u plus iv analytic function, u satisfies u is harmonic function, v harmonic function. Means u satisfies Laplace equation. Means dou square u by dou x square plus dou square u by dou y square is equal to 0. And v also satisfying Laplace equation. Means v also harmonic function. If I directly say u and v are harmonic function, you don't know what are here. U and v satisfy Laplace equation means u and v are harmonic functions. If I directly say u and v are harmonic functions, you may not understand what is harmonic function. That's why I gave.
Oh, that harmonic conjugate to each other, u and v.
Yes,
From
yes.
there, okay, sir, thank you.
Okay, students, I'll be going to end the session. So I have to go to home. I'm going to end the session. Anything else? Still 2 participants raised hand. Anybody else?